Our first speaker this morning, this is beginning the Industry Day at NPS's Moves Institute's open house. And we have several people from industry who are going to speak to us about some of their work. And they're also going to be doing demos this afternoon. And, you know, it doesn't really doesn't do us any good to bring in industry if there's no way for industry to work with us. I mean, it's great to see the work they're doing, but we're really bringing in people from industry because we're hoping to foster collaborations in the future with between Moves and its industry partners. And that's our goal. But if there's no way to do that, it doesn't make any sense. So we're going to kick off this morning with Ms. Debbie Buettner she's the director of the Research and Sponsored Programs Office, works directly for the Dean of Research. And she's the person who A, makes it all happen, B, makes sure we keep it all legal and nobody goes to jail, and you know, does all that stuff. Her office is really great about this. So she's going to talk to us this morning about how industry can work with us and make things happen. So Debbie, take it away.
Good morning, everyone. So I'm going to just give you a brief overview of the two main agreements that we use to work with industry or for industry. The primary one that probably many of you maybe have heard of is a Cooperative Research and Development Agreement, or a CREDA. And a CREDA is a tech transfer statute authorized agreement. It requires a federal lab. Naval Postgraduate School, while we're a school, Office of Naval Research has given us lab designation for the purposes of many of the tech transfer statutes. So we're not a lab, but we're allowed to act like a lab for the purposes of tech transfer. So the primary goal of a CREDA is actually to have at least one federal lab and at least one non-federal entity collaborate on a problem, take a technology to the next level. NPS does a lot of early development. A lot of the other Navy labs, you know, they'll have technologies and patents and things like that that they work with industry to maybe make it dual use or get it to the next level. We do a lot of very early stage work. So it varies across the labs how it actually works. But generally what happens is a company is interested in either one of our technologies or working with one of our faculty members. And we discuss the problem, figure out the right vehicle. And if it's a CREDA, we, sorry, I haven't had enough coffee today. We work with the PI here at NPS and the contact with the company to get an agreement in place. It helps us to protect intellectual property on both sides of the house. We get paid, actually, is one of the things too. So NPS is mission funded to do graduate education for naval officers only. Everything else that we do is reimbursable. So for CREDAs, we primarily look at them as another reimbursable activity. And the benefits of doing a CREDA for NPS is our technology gets out there. We learn something for the Navy or for DoD at large. And for the companies, same thing. They learn about what the Navy needs, makes them an asset for us to use as you know, for the national defense purposes. And we're allowed to give them access to facilities. We can share intellectual property information, all those kinds of things. And for them, they can do the same thing. They can provide us with people, facilities, equipment, all kinds of things, whatever we need to get the research project that has been identified for the purpose of the CREDA done. One of the things we use CREDAs for as well is NPS is allowed to participate in things like SBIR, STTR projects. We're allowed to partner on various DoD and other organizations proposals to the government, and we're allowed to be a sub, essentially. And the mechanism that we primarily use to actually get the funding to us from the company that got the award is through the CREDA. So we do quite a bit of CREDAs. I think active right now we have over 50. Yep, almost 50. And last year we did 21 new ones. So we had a very, very busy year in CREDA activity. And these slides are going to be available, obviously, and I'll leave some handouts up at the top as well. So I don't want to kind of read through the whole thing, but you can kind of see that we have the definition of the CREDA, basically. Again, it's a document that delineates the work that we're going to do together. It's legally binding. And CREDAs are often, they're often used for actually, like I said, getting a technology to the next level. And so licensing can occur. So if the government and or the other party develop an intellectual property under the agreement, then rights, the main thing that it does is it delegates the rights between each of the parties to the intellectual property that was developed. NPS has a, I got to how many patents do we have out there available? About 100. So we have 100 patents, and they're all on, we have them advertised on a Federal Lab Consortium website. We don't do a lot of licensing, mainly because of the nature of our patents are more early stage because of the nature of the university, right? Rather than the labs. The labs will have patents that are just ready to go without a lot of further development. But we do have, we have done a few patent license agreements as well. We can see that the kinds of activities that we routinely engage in are of course things that are important to DoD and the Navy in particular. And there's some examples there about that. So CREDAs, does anyone have any questions about CREDAs in particular before I go into the next vehicle that we use? Oh, sorry.
Sorry.
Oh, I can hear you.
Well, no, we have to get the Zoom audience.
Oh, the Zoom audience.
Hey, Bill Platt from Analog Research. About how long does a CREDA take from start to finish? One of the things that, I retired from the Army in 2018, and we've done about 10 different CREDAs, and it seems like every organization has a different approval authority, a different process. And so just wondering from an industry perspective, from a CREDA basic use case, how long does that normally take from start to finish to put that in place?
Sure, it varies substantially. Our process is pretty streamlined. We're not a giant lab. We have the legal office reviews them, the president signs them. The real long pole in the tent is negotiating terms and conditions. And we've had pretty good success without having really long negotiations, because we do work with a lot of small companies because of our really heavy involvement in SBIR and STTR projects. And so they are more willing to just accept the terms and conditions. So we've gotten CREDAs in place. I don't know, our record is something like 7 days.
I like it.
Yeah.
Perfect.
So on average, though, I would say it's 6 weeks to 8 weeks is probably average. We've had a couple that, took a year. But
Great. Thank you.
none like that lately.
All right. I'd like to say one thing about that. Is that ONR is the legal authority still, correct? And ONR has basically come up with their boilerplate legalese. And I'm violating my own. Yeah, I'm sorry. I wasn't speaking to a microphone. Bad person. So the ONR is our legal authority to do that, and they have a very boilerplate thing written through. And what Debbie told me is that a lot of times, we'll send that out, the company won't like something, we'll go back and forth, and that's really what adds the time and complexity to it. If they're willing to accept ONRs, the way it's written up, the legalese, it goes through very quickly. If they want to argue about it for a while, generally what happens is you argue for a long time, it ends up being the way ONR wants it. But you've added 8-10 months to the policy and nothing has changed. So, just kind of keep that in mind. Try to keep your lawyers in check, because they're trying to show that they are providing value to your company by changing things. And in reality, there's probably slowing things up. Is that fair?
Yeah, absolutely fair. Absolutely fair. And of course, the largest section of the document is the intellectual property and data rights section, and that's the one that gets the most attention. But basically, if you're not familiar at all, it sounds terrible, but the reality is it's a very fair set of rules about how you share.
Hi, good morning.
Good morning.
Yeah, thanks for your time. Colonel Chris McClernand, I'm the Associate Dean of Research at the Air Force Academy. So we're involved in a lot of the same activities. Can you talk a little bit about, do you have faculty here that are publishing books? And if so, how are you handling royalties? Is it through a CRETA? And do you have that CRETA with the publisher? Can you walk through how that works here at NPS? That's something that we're struggling with at the Academy.
Yeah, we have not used a CRETA for anything to do with book writing at NPS.
So I guess maybe a follow-up would be, there's the new copyright law that allows our researchers in the federal labs to maintain their own copyright.
Right.
Have you navigated, because there's no implementation guidance yet from any of the services, have you navigated how, if they did retain their copyright, they would then receive royalties on the things they did on government time?
I believe that they are getting royalties. Our office doesn't really get involved too much in the publications and things like that. I can double check when I get back to my office to see yeah. And I think I don't know if we have any guidance that we've put out that we could share. But it would be, yeah, the legal office handles all of those kinds of things for us. Yeah. Any other creative questions or other random questions I might have an answer for? So the other agreement that we use a lot is a technical service agreement. So basically, NPS has a ton of labs and centers and a lot of really smart faculty brains. And so a technical service agreement, some other organizations call it work for others or work for private parties across DoD, but it's all the same. It's all the same authority. So basically what it allows us to do is give access to our faculty's expertise, to our labs, our testing facilities. We have a lot of centers that focus on, specific things like, moves, does modeling simulation, obviously, and we have a materials lab, additive manufacturing. We've got water tanks out across the street and on the beach that people can test, underwater vehicles and things like that. So all of those facilities are actually available to the private sector. The only organization that we can't provide services to is a foreign government agency, and that's the same for CRETAs and things like that. We just can't do anything government to government that way, as much as India would like us to. So a technical service agreement usually just is a result of it's someone coming to us to ask for services. CRETAs can go the other way. We can be the reaching out party as well, looking for someone to partner with. But with technical service agreements, it's just a one-way street into us. Someone needs something, and we can provide it under this agreement. It's a service activity. There's a fee. Our time just has to be reimbursed. So it's a cost agreement. So it does have value. And you get access to, kind of some unique facilities, and combine that with the expertise of our faculty. And it can help you solve a problem. It can help you test a prototype. We can do all the data analysis, and we just give you the report at the end and the results. And it's a very quick and easy way to maybe help get one of your technologies to the next level, or solve a problem. We've even started using these agreements for doing training workshops and things like that. So we're sharing our expertise via doing a workshop. So someone might have a training requirement, and we have an expert in it, and we can do develop a week curricula, deliver it to you, and we just get reimbursed for our costs. So it's a very flexible agreement for random things to be done. Anybody have any question about that? So another way you can work with NPS is actually through the patent licensing process. So we have about 100 patents out there. And if anyone is interested in any of those technologies, one of the ways you can incorporate it in your requirements is to pursue a patent license agreement with NPS. Often a creator could be involved in that as well, because if they really want the inventors or other NPS expertise involved in what they're going to use that patent for, then we would do a cooperative research and development agreement for that support.
Yeah, I have one question about TSAs. I guess it's kind of the comparison between the idea of a TSA and a CRETA. Like, for example, right now I have a CRETA with a company that we're working on an SBIR together. But mainly, I'm doing research and, training service. I saw that fall under that. Which is the better vehicle to do, and how do you determine which is the correct vehicle? I guess is a better way to ask the question.
That's a good question. So basically, we try and get as much information about the requirement as possible, and then it's our job to pick what is the most appropriate vehicle to use. So we don't have a lot of authorities at NPS. So it's usually a short list for us to consider, and really we just see what fits the most. One key thing that we look at for CRETAs in particular is what is the probability that intellectual property or important data is going to result from that collaboration. Then we would use that. So a technical service agreement, there's really usually not any collaboration between the parties. It's like, here's my jet engine, run it through your lab and give me the results. And so there can be like technical involvement with the party, like if we're using we're doing some analysis of the device or whatever it is that they've given us, they're allowed to obviously help us know how to do it and use it right, and then give us the parameters that they're looking for. So but it's not really collaboration, and we're not expecting any intellectual property to come out of a technical service agreement. So that's how that works.
Okay, I think that's
Awesome.
it.
Okay,
So great.
thank
Thank
you.
you very much, Debbie. I really appreciate it.
Thank you.
So our next presentation is by two MOVES grads. We have Lieutenant Colonel, retired Marine Corps type, Byron Harder, who also has a PhD in there. And I never know, the Germans have like Herr Dr. Lieutenant Colonel or something like that. I don't know how to do it in the US appropriately. But Byron was the first Marine officer to get his PhD here. And they actually now have a program. And we have two more Marines who are involved in MOVES now. Matt Morse, who you saw present yesterday and is going to defend next month. And Lieutenant Colonel Scotty Black, who's just probably about a year in, I believe. We also have Lieutenant Colonel Michael Pavek, United States Army retired. Both of them went through, were great MOVES students, come through, they did the rest of their career and have retired. And now they're both working for Improbable US Defense, which has a strong game industry and, strong game aspect, and does many other things very well. So I'll turn it over to them. I believe Mike's beginning.
Yep. So first of all, thanks, Barry, and everybody on the NPS staff for helping put this together. It's a super exciting opportunity. I apologize for not being able to be there in person. I ended up with a bunch of business trips stacked all on top of each other, as well as my daughter's graduation. So apparently I needed to be there for that. just a real quick, I'm just going to introduce myself and Byron here in a second. As far as myself, I'm a retired FA-57 officer. I retired back in 2018, and then I entered the automotive development world, doing modeling and simulation, and eventually moved over to Improbable, which we'll talk about in a second. I was at NPS from 2012 to 2014, and actually went to school with people like Dave Parks, Mike Donaldson, Matt Morris, which I've been able to see throughout today, as well as even crossing paths multiple times with people like Bill Platt and many others that I think are there in the audience. I can only see the back of a couple people's heads, but to the back of those heads, hello. So I'm going to pass it over to Byron for a second for him to introduce himself, and then we'll keep moving. Byron?
Hey, let me do an audio check before I start running my mouth. Can you guys hear me?
Yeah, you're good, Byron.
Okay. So Byron Harder. So how did I get here? I'm a second-time offender at NPS. I went there first for the master's in computer science. Then I went there again with the Marine Corps' intention was for me to get a master's in moves, but then through some interesting turns of events, I was able to turn that into a PhD program, just in the right place at the right time. So that was a great experience. And I went from there to the billet that Lieutenant Colonel Mike Donaldson now holds, the one and only Lieutenant Colonel 8825 Modeling and Sim Officer billet in the Marine Corps, and that's a Training and Education Command. So all the problems that Mike has now, I probably created. And then from coming off the tail end of that, I was able to take advantage of the Skill Bridge program and do a internship at Improbable. The timely arrival of Mike to fill my seat before I left was probably a contributing factor to my ability to do that. But that worked out great, and I had a blast, and didn't step on my feet too much, I guess, and Probable decided to keep me around, so that was my full-time job. But since undergrad in computer science, I've always had a lot of interest in things like algorithms and scalability and performance and things like that. So Improbable is a place where I get to take advantage of my interest there, and I'm having a great time. And I heard a lot of the panelists, I think it was a day or two ago, talk about, you don't necessarily have to get a hardcore technical job, coming out of the MOVES program. But hopefully I'm evidence that you can, if that is your bent. I think there's a strong technical background that you can take that pretty far. So I'm having a great time where I'm at. I'll turn it back over to Mike.
Yeah, and Byron is one of our lead scientists over at our applied modeling team. So he's absolutely essential to what we do on any day, any given day. I'm a senior technical product manager, so I just kind of make things up as I go along. Full disclosure with this presentation, Byron really did most of the work. I just turned it into dark mode. But let's get started. What we wanted to talk to you about, first a little bit about Improbable. Improbable started off as a gaming company, really focused on how to deliver massive multiplayer technology and being able to scale those games up to a large number of players as well as high density counts. They quickly realized that this would be an opportunity also within the defense space and established a UK defense organization. Improbable is a UK-based company. And then they also stood up a separate US branch, subsidiary, which we're all a part of. And so what we wanted to talk to you about today was actually kind of how we define scalability internally, and really kind of how we can use that to expand what we talk about when we're using the term scaling, and what does that mean, and how do we work with industry on that. Give me a second, I'm going to set up. I won't be able to see the chat, so if there's any comments or questions during that, if somebody could just speak up. Okay, what we're going to talk about is the 4 axes of scale, as well as some implications of that. So based off of time, we're going to keep moving forward. Okay, before we kind of really get into the scaling discussion, just a couple terms that we use internally. These are all real familiar terms, but we have kind of our own internal definition that are probably worth discussing a little bit. So when we're talking about entity, we're talking about some sort of abstraction of a real world thing, whether we're talking about a person, a building, a road, a tree. These are all fall within the category of entities. Attributes are just some sort of value that's attached to that entity. When we talk about system models, and the whole term models can be used for things like a land model or for things much more specific. But in this case, we're going to be talking about how an entity attribute changes via some sort of interaction, which is the next one. So interaction is just a computation that requires information and then changes states. And then with a synthetic environment itself, so we have lots of discussion on what is a synthetic environment, what is a virtual environment. So for our working definition, what we use is its entities, models configured for a particular time and place. The runtime software is just that piece of software that helps kind of schedule, coordinate, and orchestrates both all the models and entities, and then moves the simulation is what moves it over time. But it's the definition, the SE is kind of real critical and it causes a lot of confusion that we've discovered. So this is what we use with people. Okay, so let's talk about the 4 axes of scale, which really are extent, depth, breadth, and replication. And so, actually, I think I skipped one. Oh, I guess not. Okay, so the first one is extent. This is kind of what we most typically think of when we say the word scale, which is the number of entities within the synthetic environment. A lot of times you'll hear the word entity count, entity density, just the number of players involved. And in fact, that tends to be like the number one definition people use when they're trying to define scale, but we know that there's some limitations with that. But as far as what extent itself is, one of the things that we took a look at was how do we increase the number of players within a certain density of space. Typically within your normal game servers, you can get a couple hundred of players into a certain space, but that's about it. And then what we have is a lot of different servers and a lot of different spaces, kind of chunked out through time and space in order to give the feeling of a dense environment, but in fact, it's actually not dense. So one of the things we did was we developed something called Morpheus technology and created a game that could really consolidate a lot of people into a dense space. This is called Scavengers, and we did some experimentations called Scab Labs, where we got thousands of people into one space. It was a bit of madness, but it was really, really awesome to see. And then the question is, can we then take that technology, that Morpheus technology is what we call it, and apply it into a military sense? And that's what we did within 6 weeks for both the British Army warfighting experiment, as well as we demonstrated this at ITSEC. There are a lot of challenges with doing extent. And so some of these challenges are listed to the left, but I'll just kind of highlight a couple of ones. One is just doing the configuration and setup. The next is the runtime computation. So we're going to talk about computation in a couple of different places, but really as we have more entities, you're going to have more interactions, and those complexity will scale exponentially or increase exponentially as we go along. The last one at that bottom talks about authority changes. And really that when we talked about previously in the game space, but even in this space, when you have a lot of different servers, a lot of different areas, and it's that handoff of entities from one server to another, that's authority changes. And so how do we address some of these problems? They're listed on the right. As far as one, we can do automation that can help you set up the simulation easier and set up those entities easier. You can always improve the behaviors themselves, apply more automation, take less load off of the users. One thing that we work very hard on is that distributed compute, being able to run things in the cloud and being able to offload various processes throughout the time. A lot of this is known as sharding, as well as how we separate things out. Then as far as dynamic authority solutions, what that really means is being able to do automated handoffs on a rapid basis and based off of as loads increase and decrease. The next piece is depth. So while scale talked about the number of entities, depth really talks about that level of modeling detail. That's what we think of when we say things like fidelity, resolution, really how complex, or I should say how in detail does that model go. So on the right, we have two diagrams. One is for HTNs and the other is really kind of that engineering level of simulation that occurs within that model. One of the things that I did after the Army was actually I did the test and development for in the automotive world, and I actually did tire development, which was, I thought, okay, how complex could a piece of rubber be? Turns out it's really, really complex. A lot of things go into it. So how do we increase that level of detail within the model? A lot of challenges with that, everything from data collection, conceptual and modeling. And actually, there was a great comment, I think, on the first day about conceptual modeling and the importance of it. We're actually going to come back to that here in a short period of time. Another common challenge that you're going to see is BVNA, and particularly when we're talking about human behaviors, as well as novel or unique situations, and how do we validate and make sure that that's operating as we would expect it in the real world, especially if we've never seen it in the real world. Configuration time rears its head again as far as getting everything set up, as well as the complexity of runtime computations. As far as solutions to that, so the first one we got is this marketplace modularity and metadata. Really, how do we put models together into a certain marketplace that are all compatible either with each other or to the degree that users can require. Specialized tools and services. How do we make these special tools that will really specifically help users address the modeling needs that go through that? And that kind of relates back into the authoring tools. One of the big things we take a look at is how do we allow users to do SE composition faster? What are those steps that we take that need to be reduced? And lastly comes back to kind of that multi-core distributed compute that allowing us to offload a lot of the computational loads across the cloud environment that we have. Right. The next one is breadth. And so we've talked about scale, we've talked about depth, and now let's talk about breadth, which that is really the number of entities or model types. So it's not just for clarification. So really we're talking about whether we're talking about multiple domains, whether we're talking about multiple echelons or layers. Really, this is where we start typically seeing and thinking through a federated synthetic environment. And this is where the complexity really starts to kick in and increase. Lots of challenges. So let's talk about the first one, is conceptual interoperability. So on Tuesday, one of the instructors talked about how he works with students to develop the conceptual model, because a lot of students walk in and I want to do a synthetic environment. But he forces them to sit down, slow down, and take a look at kind of what do we want to achieve. When we start looking at having interoperability, that conceptual model becomes even more critical. Arguably, one of the most critical elements of getting interoperability to work. So for example, if somebody creates a land model with ground forces and land-based artillery fire, and I'm creating a model that will do CAS, if we have and we're going to have different ways to model that. If our concepts are too different, no level of interoperability is really going to be able to fix our problems, because we're going to be thinking the world so differently that those two concepts won't match. We can do fixes in there, but as far as perform, we're going to see a lag in performance and just sorts of issues. So that conceptual interoperability and taking that time to understand it, that it is pretty critical. Other challenges is you get a lot of proprietary rights or providers may be willing to collaborate, maybe they won't. We always run into still the VBNA issue, which we talked about earlier. And at the bottom talks about multi-level security, which we know is a common problem throughout and a very big industry problem overall. But especially once we start talking about putting simulations on the high side, as well as multinational, this becomes a big necessity. As far as potential solutions, we got some similar ones as far as marketplace, but we also take a look at how do we create that those modular architecture and adaptive interfaces that allow us to connect each one of those models. There is no magic bullet for interoperability. It's just a lot of work and nugging through. We could talk about standards, we could talk about all these other things, but ultimately, because you're going to have differences in conceptual models, it's just some roll up your sleeve work as far as making things work together. As far as domain and functional charting, how do we separate that within a computational space comes into effect. And yeah, lastly, as far as surrogates, so let's talk surrogates at the bottom. One of the things that you're doing when you're trying to build interoperable models is you're trying to figure out, how do I do this quickly? How do I provide maybe a slightly lower level model that would be interoperating with myself just to make sure it works? So that's where we can come with a surrogate. Maybe it doesn't have the same level, but it provides the input needed for that model to keep going and for me to develop it. And the last piece that we'll talk about is replication. And really that's talking about number of copies of the SE. Or another way to think of it is number of instantiations. How do we do how do we run multiple iterations at the same time? How do we parallelize our workloads? This particularly comes into play within an analytical sim, where we need to do thousands of iterations at a very rapid pace. But it can apply to multiple things, even on a training environment, when we have multiple instantiations of the training environment running simultaneously. So there's lots of challenges with that in terms of doing operations management. That's just talking about our IT support, that backbone that we have to have up and running. The other thing, you see something that I call cursive dimensionality, and that's where as we increase the possible space within the simulation, as we add more dimensions, our data points get more spread out. So think of it as if you have a bunch of people in a room, and at one floor they're fine and they're kind of crowded and they're good. But if I start saying, okay, now everybody's spread out vertically, everybody can fly, they're going to start getting more space spread out, and suddenly they start to feel kind of lonely. That's the issues with dimensionality that comes into play when we start talking about doing high replications. There's things that we can do to address that. That's called space filling designs, as well as surrogates. But it's always an issue. The other thing that we can do is, you see hybrid bare metal. Really what that is on-premise resources as well as cloud deployment. So you'll do some on-prem, and then you also have it simultaneously running on the cloud together. Edge computing, you'll hear about. Really, that's just the placement of the compute resources in relationship to the users themselves. So if I can get a server closer to you, for example, you're gonna have less latency and less lag experience. I think I'm running close on time. I think my time ends about now, so I'm going to kind of wrap this up here. When you're taking a look at and trying to figure out the synthetic environment, there's a lot of things you have to consider. You're going to consider what, and these are fairly common. What is my purpose? What training, rehearsal, analysis, and that who are my users? You'll also be thinking about what do I have to model itself, and what is the level of modeling that I need. And then as far as the architecture, do we have a monolithic application? So when we think about like OneSAP is a big example of a monolithic simulation, or can we just do a lot of small simulations to do that? One thing that we always want to kind of hesitate is you can always look at other places and you should look at other places for solutions. We're talking right down here. However, just to be aware that, anytime that you're looking at solutions that may or may not fit your use case, that they're not a forklift solution. In other words, they're not just something that you can just pick up, carry over, and apply. There's always going to be a certain amount of integration or work that you're going to have to be doing with that. So, in conclusion, we talked about scalability as a multidimensional challenge within we listed 4 axes. With the axes itself, it's we kind of talked about what breadth, depth, extent, and replication, and really where does your organization, where do your requirements fall into those? Because as we start planning, what do I need? Number of players, What do I need in terms of depth of and fidelity? What do I need in terms of how many instantiations do I need to run? It all falls within that scale. So as far as implications to do, take a look at our advice to you, take a look at all the solutions available across each one of those axes to kind of get an idea of what's available and what can apply for you. Understand the level of complexity that you're getting into, and the amount of change that could be inserted as you start to build your synthetic environment. And then just reach out. We're happy to chat. I'm going to turn it over. Byron, do you have anything else you want to add?
Just to highlight that when we're talking about scale, it's not just the running time of a single synthetic environment that can be the challenge. It's also the time to create the synthetic environment and the management of it. All these things come into play. So by thinking about all the axes of scale, you can help to uncover where all those challenges are going to arise and what solutions you're going to need.
Great. Well, thank you very much. That was a great presentation. Fortunately, we don't have time for questions. No, I can set up a laptop in our demo space. Would you guys be able to participate then from at 2 o'clock Pacific for a while? So if people have questions for you, they want to kind of do a Zoom and you might be able to demo some stuff from there.
What time is it again, Perry?
1400 Pacific.
Let me double check here. Do as far as like do Q&A?
Yeah, just that's where our demo, you guys have been to the demo nights before. People just walk around. We'll have a laptop there and you can be on Zoom and they can talk to virtual Mike and virtual Byron.
Yeah, I should be able to be there for about half an hour.
Okay.
Byron, can you join?
Yeah, I can probably do about the same time.
Okay, excellent. So we'll have you there. So if you have any questions for Mike or Byron, please drop by there. But please join me in thanking them for a great presentation. Okay, so we're gonna have another presentation from industry. And Hysos Tech is a company that has some really neat technology that we've seen. They've been hooked up with Chris Fitzpatrick for a few projects. We saw a demo of their stuff. We were really glad they came and decided to share with us at the open house. So our presenters are Dr. Paulo Barthelmess and Sean Johnson, and they'll be presenting on their natural language mission planning tool that they have. So Sean, please take it away.
Well, thanks for the invite, especially to Chris and to Kurt. Been enlightening, fascinating, great campus. Just really appreciate being around all these great minds. So we're going to talk today about Hysos Tech and superior mission planning through speech and sketch. So a little bit about us. We're a natural language company, and we're the creator of a product called Sketch Through Plan, which is an AI assistant for C2, turning natural speech, sketches, and handwriting into actionable data for C2 simulators, or really any map-based system. The solution has been built off decades of academic research and 10 years worth of DARPA projects, Deep Green and Kalo. Deep Green was kind of it was focused on planning. And that's too narrow of really what it was about. It was focused on planning, but it also included, wargaming and some predictive modeling. It was quite a fascinating, forward-looking project, and I would encourage you to go look at it and read about it. We offer AI solutions in natural language processing, computer vision, and computational linguistics to extract meaning from combined human sketches and speech. And we're empowering cognitive superiority, enabling the warfighter to tap into today's powerful AI capabilities with a natural and accessible human-machine interface. That's done by avoiding the cognitive disruption due to tool complexity, or what the military often calls buttonology, right? Removing those buttons. And we improve training and mission readiness because we shorten the planning cycle and leaving more time to develop more refined plans and rehearsal. Lots of different capabilities. We have SDKs for extending Sketch Through Plan that are available. Some are open source. I'm going to demonstrate a workstation version of it, which is based upon ArcGIS Pro. And we've got some in development and ideas and prototypes around end user edge devices. We're talking with NPS about this for the Marine Corps, and human machine teaming for controlling and interacting with autonomous systems. So I will say one of our driving motivators, it was a quote from this great man. He was internationally known, locally known really, because he visited this area. He was a world-class engineer, environmentalist. We all know him. I would argue that he's even universally known. Montgomery Scott, a keyboard, how quaint. So this is our driving force. So what I want to do is what you shouldn't do is I'm going to do a live demo for you. Good luck. Yep. There you go. So this is, if you've ever seen ArcGIS, this looks a little bit different because ArcGIS is the best, greatest, does everything GIS system out there. It's deployed across the DoD and D6A and D6MC, but it's hard to use. It does everything, but it has 1,000 buttons, right? And so the soldier doesn't lean towards that unless they're highly trained specialists to know how to do that. So what we want to do is we want to remove those buttons. And this interface is no buttons, right? I clicked one, which is our sketch tool. And so I'm going to go ahead and do a real quick COA for you. Enemy mortar platoon. Enemy artillery platoon. Okay, so very quickly I can add this. I'm going to go ahead and push one more button just to show you a bit more of the capabilities. I'm going to move into a role, so we can actually play roles and we can limit. Now I said enemy, and so that told it what to place, the type of 25-25 symbol to place. But if I set it in a role, I'm going to be even constrained to those roles. And in this case, I loaded an ORBAT, so I can just use the designator. Alpha 269. Objective Wildcats. Main attack Seattle. Bravo 115. So I'm going to stop just for a second to show that very easy to lay down symbol graphics. But the real power that's happening, so that's our NLP. The real power is our computational linguistics. So as I'm drawing all of those symbols on the map, I'm actually creating all of the simulation ready components to push to a simulator right now. I don't have to do anything else. As the warfighter, I don't have to do anything but push the next button, which sends it to a simulator. And this is work that we've done either by bridging technologies or currently working with NPS on the CWIX project. So this was Dr. Blaze talked about C2 Sim. So in this iteration, we're enabling C2 Sim to push to any C2 Sim compliant simulator. So I will demonstrate pushing it to MOX VR Forces, but we could push it to Mossa's Sword, which is the French. We can push it to the Cora simulator. Actually, that will be happening about next week when we do that final test. But because they're C2 Sim compliant, any of those simulators can be done. So we're enabling. You see here the military doctrine. So as I look here, we see that Alpha 269 attacking objective Wildcats along axis to Seattle, and that doctrinal piece, they can attack to secure or fix or seize or destroy. And we can push a button there if we want, or we can just continue planning here. Destroy. Right, we can just do this too. A little bit off the screen there. Objective Bearcats. Supporting attack Trenton. Company boundary 269 north, 115 south. Forward line of own troops. Phase line blue. Okay, real quickly, real intuitive. For an expert user, an expert being somebody I've trained for half hour, right? They can really get into this. For a novice user, somebody to walk up, they know doctrine. They can actually start to really easily do this. We would say that even a general can do it, right? They don't want to know technology. Now, I showed that piece, but what we've also been doing here is we've been building this at the same time in Google Maps. So I don't have to be in Pro. I could be in Google Maps. Attack helicopter. Rotary wing axis of advance. Okay, and we see that piping in through here. So now we're talking about a true collaboration across the globe. And this is what we're doing with CWIC. So we have MPS here using Sketch through Plan and other people all over, but we could have a web browser being that interface. So you could have OP4 on a web browser. You could have friendly planners on more sophisticated, whether it be desktop or server. So it's truly that. Now, I'm not going to I'm not going to do the simulation piece live because running VR forces on my system is a bit of a hog, but I will, if I find my video, I don't know where it went. My video died. Give me 2 seconds here, and I'm just going to show you a quick video here. So here's a pre-canned video of, this is kind of drawing that. Tasking, okay, here we go. Come on. Okay, so here what we see here is we see the C2 Sim GUI over on the left-hand side. This is kind of what it's a GMU project they built. We have VR forces up top here. We've got STP here, and a plan has been developed. And we're going to send an initialization file. Okay, and you'll see what happens that it actually pops the same graphics into VR forces with the push of a button. So here come the graphics popping in here, and then we're going to go back here, and this could be automated into one button push in a future version. But we're going to go ahead and push a button here, which is send the order file, and then we see through the magic of sped up video that we run that simulation. And there was nothing more to do than the user to speak and sketch, create that, push the buttons, run the simulations. And right now we look at that. It's not great. We quickly change that plan. We run those simulations again. Okay, so let me go ahead and go back to my PowerPoint. Talk about, right? Today's soldier expects Alexa for the military. So this is why we build. Today's solutions are slow. Planning faster leaves more time for execution and repetition and puts us inside the adversary's OODA loop. Current UIs are hard to use. They require significant training. Every system has its own UI, right? And so we're doctrinal, so we could actually be on any mapping system, right? There's no really dedicated planning tools out there today anyway. UI requires high cognitive focuses, and soldiers are fatigued under pressure already, and the solutions are evolving slowly. So as we focus on our near peer adversaries, our solutions must evolve for the future and current soldier. And there was a lot of talk about requirements. If it's not a requirement, it doesn't fit. And so what we were told by the STIACM was like, no, you fit the requirement. The requirement is ease of use, automation, go faster. That's the overarching requirement. So this is exactly where Sketch through Plan fits in here. Okay. So today's tech for today's warfighter, robust AI capabilities. So the automatic task recognition, which is automatically perceiving the planner's higher order intentions, generating the task matrices, the sync matrices, and provides automated simulation feedback to guide planning the tight adjudication loops. Natural language, the natural language of the spoken doctrine is the user interface. It's fast and intuitive, and it fuses the user speech and sketch for COA symbol laydown orders of magnitude faster than traditional current UIs. And we're built on a microservices architecture. Another, buzz, we built on this decades ago. We actually, before microservices was called microservices, that's what we really built. And we've integrated into ArcGIS Pro. We've had these APIs, but we've also done previous integrations into CPOF. So we actually can have voice-enabled CPOF back in the day. We did the same thing with C2PC, Tiger, in-vehicle JV5 systems. I used to have a JV5 in my garage that I had to give back, right? And also some commercial like Boeing Tapestry, and then simulators, LG Raid, which is a commercial simulator. So OSWAP is what the Norwegians are using, VR Forces, Sword, and Cora. So the benefits to the soldier, enhance cognition. The operator avoid traditional distraction. They can focus on the task, not the tool. The system complexity is reduced by automatically recognizing the intention. And reduce training on specific systems, because we have integrated into these systems. We believe that we can be a universal UI for any mapping system. And so reduce the training across the board. And system proficiency becomes a function of the user's tactical and domain knowledge, not system unique training. And we can improve planning via automated analysis, fast creation, high quality COAs, ready for automated plan execution and analysis, providing leaders the opportunity to explore multiple options and ultimately optimal option. Because today's planning process is so long, many times we understand one plan is provided to the leader because it's too hard to redo those things. They take too long to do. So we think we can improve on that. And we talked about the C2 systems to drive simulators, populate C2, or control complex systems. So where we fit in schoolhouses, right? Reinforcing doctrinal training, and as a planning practice tool, replacing paper or whiteboards or grease pens. I mean, those things still exist today, and we can replace those. For military planners, supporting fast, high quality planning, compressing that OODA loop for tactical and strategic operational planning. And then we've got other dual use potential around emergency services and future human machine teaming. So building trust through natural language to those autonomous systems, right? And having this natural user interface to those systems and controlling them through doctrine and building that trust with them. Okay. So used on many different devices. We've done it on whiteboards. We've done it on a 30-foot board. We've done in-vehicle systems, and we've done some on tablet handheld systems as well. So more than just a pretty picture, right? We have over 4,000 25 symbols in there, and that can grow to whatever. There's no limitation there. The multi-step tasks are automatically recognized. Instant creation of these other matrices. We have role specific, like I talked about, and also probably upwards. And we have additional product panels that are available and possible. So task matrix, sync matrix. We could build the task orgs, load them in, or build them here. Targets panel, fire support matrix, directed obstacle for the engineer, directed obstacle matrix, and an ISR tab. So all these things are capable, voice enabled capable. And I'm going to provide the deck so you guys can at your leisure take a look at these things. But these are live videos of our integrations into JCR, JVCP, Android, CPOF, C2PC, Tiger, and we have others as well if you'd like to talk to us. Simple interface, fusion of voice and sketch, removing today's complex UIs, AI-based, compressing the OODA loop for automated analysis and wargaming, multiple options for the leader, enhancing cognition by using military doctrine as the UI, automatically perceiving the planner's higher order intentions on the fly. And so that's it. And I will just point to the picture. This is actually a demo on a 30-foot board. But if you can imagine trying to plan on a 30-foot board and having to go find that next symbol on a palette, which is somewhere up in a menu item, and then it pops over 10 feet away, and you go find that, and you want to place it over on that thing. And we enable this type of capability through speech and sketch. And the last thing I will say is that we have has some traction with the Army. We're engaged with DevCom and STTC. They've integrated us into their battlefield visualization and interaction system. That was demonstrated at PC21. And the 82nd Airborne actually presented us as well on a kind of a tabletop sort of thing. And that was the ArcGIS Pro. DevCom's using server-based capabilities on the web, and 82nd was using more of an ArcGIS Pro integration. So, any questions? I don't know what time it is.
Yeah, no, we have a couple minutes for questions, so great. And we actually have one from the Zoom audience. John Morgan, former Deputy Director of Moves, asked, have you tried loading this on a combat system like an AH-64 Apache for in-flight planning?
We haven't. No. We'd love to. Give us an opportunity.
Thank you. Clay Grunke, Moves. This slide actually does a good representation of my question. Is there any interaction right now between the person at the board and the map, or is that just them having a pen at the map?
No, it's just like what I demoed. Yeah, so they're interacting on the projected board, right? With one of our partners. They project 30-foot boards. And yeah, so they're touching with the pen and speaking, just like I did here. Okay. On there and creating the goals.
So that pen is being tracked in space and mapped to the board somehow? Okay, cool. Thank
you. Ivar Oswalt, supporting Navy Modeling Simulation Office. I was wondering about the application on the OPFOR side. Has it been used? I mean, I would think something like this, if you're on the blue side, I get it. But on the red side, okay, we think red is over here. We think they're this axis of attack. We have this confidence at this particular unit being here. You know, I could see it, you know, laying out that red laydown really quickly. And maybe with the AI, with some adaptation capabilities and with some uncertainty built in, so you could run scenario, you could iterate different options based on that uncertainty in your simulation environment. Has it been used in that context at all?
Yeah.
So the notion, particularly from Deep Green, is that you would get full co-creation on both sides and just play pairs, right? As you would expect. I think to the more central thing that your question points to is that the real value here for STP is the fact that we make this data available digitally immediately, right? So there's no delay, it's all there and it's all ready to be exploited by whatever techniques you may throw at it. So all the things that you said, I'm really excited. Yeah, sure. Yeah, now I have these entities over there, and I have the already the human interpretation of what the action could be. So getting that special sauce in there. What can I do now to bring in the extra AI to make this really shine, right? So that's perfect. I would like to talk to you more about your ideas and see how we could integrate this in here. But what STP does in essence is open the door for exactly these types of things to take place and more, even more conventional stuff, right? So you're running in ArcGIS Pro or some other mapping system that may have some facilities to show visibility and right? You can show these circles of ranges for mortars and other threats. So no limits to what you can do. You can really transform planning by throwing more AI, and that's what STP does. It's the data is there. Now you can just play with it.
Thank you. Unfortunately, I think there's a lot more questions out here, but we don't have time for them, Matt. But you're going to be at the demo.
Yep.
And so please head over to the demo, ask your questions. I think this is really great technology. So thank you very much for coming and sharing.
should be audio too.
Should be audio.
Yeah.
At this point.
That's fine. Not yet, it'll come.
Okay.
Nomad 2-3, this is Viper 9-1, pushing Coral for your work.
Viper 9-1, Nomad 2-3, proceed back to Coral 3K and below. Advise ready for gameplay online.
Viper 9-1's ready.
Type 2, bomb on coordinate, 2 by Kilo 2 Alphas, 30 seconds. 9-line as follows. Coral 336 4600. 1280 feet, 2 by APCs, 8-digit grid, 11 Sierra, Papa Sierra, 7387 8241. Nomad 23 lasing 1111 east 2500, egress back to Coral 3K and below. Advise ready for remarks and restrictions.
Viper 9-1's ready.
Laser target line 295, final attack headings 310 through 350. Standby TOT, go with system readbacks.
Viper 9-1, copy all, standby. Viper 9-1 reads back 1280 feet. Papa Sierra 7387 8241. Laser target lines 295, final attack heading 310 to 350.
Viper 9-1, good readbacks. What's the earliest TOT that you can make?
Viper 9-1 can make 30 TOT.
Copy 30 TOT.
Viper 9-1 reads back TOT 30.
Good readbacks.
Ten seconds.
10 seconds.
Viper 9-1's in 350.
Viper 9-1, cleared hot.
Laser on.
Nomad 2-3, lasing 1111.
Left of 1, time of flight 15 seconds. Back, cease lasers.
Cease lasing.
So while Perry cues that up, good morning. How many times have we seen a demo or we watch a commercial on TV and there's a caveat there that says not actual gameplay, right? Well, what you just saw there was actual gameplay, actual training with Marines and pilots, getting training and readiness codes and updating their currency via the use of link simulation. So good morning, my name is Steve Mount. I'm here to represent 1st Marine Expeditionary Force and our team from Booz Allen Hamilton that is doing this thing every day. So utilizing the systems and simulations that you're developing here, the academics that you're learning, and applying those to training of our Marines in a link synthetic environment. I'm here with my colleague, Chris Getchell. These are kind of things we're going to talk about today, a little bit about our team, kind of our role at the Expeditionary Force, a little bit about operationally adaptive simulation integration space, OASIS. We've hosted several NPS students down at our lab to introduce them to this technology, introduce them to kind of how we are linking sims together to further training for our Marines. It's a great example of typical Marine Corps where we're trying to do more with less. Everything I'm talking about today are currently available systems or simulations provide to us through programs of record. And then lastly, Steel Night. Steel Night is a perfect example of not being afraid to fail, not being afraid to try new things in a training environment and possibly coming up short. We'll learn from those mistakes and provide better training next year, hopefully, for division. So not like Commander Kane, I didn't hand out any acronym sheet. Here, just our list of acronyms. Unfortunately, we all live in the space where not only are we part of the DoD, our individual service, but now modeling and simulation, right? Where very detailed acronyms, no test later. Who are we? So we're a 4-person team. We work at the MEF command element level. So that is a 3-star headquarters at Camp Pendleton. And we've been around since 2014. So 2014, large scale exercise. Our current 3-star Lieutenant General Tulin said, hey, let's try to increase the value of training by linking a bunch of simulators together to increase training across the depth and breadth of my MEF and not just my staff. So then we've been doing that for a while. We currently fall under the G3 FEC, the Fires Effects Coordination Center. And our role really is our 4 focus areas down there at the bottom of the slide. We're there to go all the way from individual to collective training for units and the MSCs across our MEF. We're to assist the MEF command element in naval and joint integration. And then we also advocate for the MEF's equities at the service level and LVCTE going forward. Okay, a little bit about Operation Adaptive Simulation Integration Space. I'll just go ahead and call it OASIS from here on out. We went online in summer of 2020. So just a couple of years now that we've been doing it. It's a dynamic simulation space on the air station in Camp Pendleton. So we are co-located with the HMLAs, or Light Attack Helicopter Squadrons, there at Camp Pendleton. And the capability is then to link our JTACs and our FACs with our manned flight simulators. How do we do that? We use some of the technologies there on the right. ASCII Voices is our radio over IP solution where we translate synthetic voice either in our lab or live radios coming in into simulated voice for the aircraft. Virtual Battlespace 3 is our first-person shooter. We bridge our DIS for Virtual Battlespace 3 over to the HLA environment to ADTE. You'll hear that word a couple of times. That is the aviation training network that most of our flight sims are hosted on. And their constructive sim is the 10, so the Tactical Environment Network. So we are integrating our VBS3 environment with their 10 environment and then displayed through their image generators into their cockpits and into their weapon systems through our lasers. The key to me and the key to our Marines, right, is having this persistent capability. We've gotten to the point where through Marine Aircraft Group 39 and the MAG, where we can have sim slots on Mondays and Fridays where JTACs and pilots can pretty much give us an hour, couple hours notice to a day's notice if they want to run a scenario. I link up with the aviation flight sims, push a couple of buttons through a really easy GUI, and we're training, right? It's not a months-long process to integrate these things. It is simply get the bridge up, know what the objective area is, and Marines are training. Going to go to a couple of use cases here. You'll see the OASIS as the building block, where we then start adding other pieces of the Air Ground Task Force to expand the training besides just our pilots and our JTACs. So here's a quick representation of how the room is set up right now. I'm not going to go through every single station. It is what it is, right? We have laptop-based machines running VBS3. We have 2 observation posts. They're not always used, but it gives the ability to be one embedded with a maneuver company possibly, and then one a reconnaissance platoon or something like that out forward. We divide the room just for space, and then UAS operators, possibly an FSC's Fire Support Coordination Center in the back, who then clear those fires for our Marines as they're running the close air support attacks. We're running our virtual battle space local area network here off of a scenario server. So one machine is running the scenario, everyone else is just interacting with that. Where the magic is really happening is over in our server room. That's where our ASCII voices is located. So that's translating our digital voice to the flight simulators. And that's where our disk bridge created by Verax that then creates our environment, shares that with then ADVTE and the manned flight simulator environment. For those of you who aren't familiar with ADVTE, it also allows us to connect with Second Mall out on the East Coast. So their flight simulators there. We can also connect to 29 Palms and various other locations. So quick example, Marines, every spring, every fall, go to a class called WTI, Weapons and Tactics Instructor course. And traditionally, the air officers or our ground combat element have trained to go out there in a totally separate environment than our pilots. A couple of years ago, when we started Oasis, let's say, hey, let's get our infantry brethren and our pilots together before the course and train in a collaborative environment. So when they get to the course, they already know each other. So we run now every spring, every fall, primer classes to prepare them for WTI. Another layer on top of that now is let's take the Oasis on the right-hand side and add multiple flight simulators, not just attack helicopters, utility. Now we have assault support forces practicing pre-LR fires, post-LR fires, that handoff between the aviation FAC-A and then the ground combat element in placing guns. As you get to complexity with multiple fires in objective area, that's the benefit of simulation, where we're practicing things in a synthetic environment before we go do it live and waste gas up in the BP waiting for a 9 line. Next layer on top of that is now we add in our air command and control element. So you'll hear CAC2S. So CAC2S is our air command and control system that takes multiple different inputs. It is a radar system as well. How do we integrate with that? How do we take these synthetic tracks via DIS and stimulate their system so the radar operator is now looking at both live aircraft on his radar as well as synthetic injects? Okay, so I promised I would talk about Steel Night. So it's not all roses and daisies, right? Steel Night is an annual 1st Marine Division exercise. It is traditionally a live fire combined arms exercise out in the desert where Marines practice what Marines do, right? Shoot, move, communicate, blow things up. Past year, 1st Marine Division came to us and said, we not only want to do this live, but we want to practice in a synthetic environment with our naval counterpart, ESG-3, and practice some specific O-plans. So our team, along with EWTG PAC and the Battle Sim Center, had to come together and say, okay, how do we translate their training objectives into systems? Systems and simulation that are not only geospecific, have a complex maritime scenario, and possibly have competing training requirements, right? So you have the MAW involved, you have the division involved. Sometimes their training is in conflict. So it was our point to I kind of show this as, building the puzzle. The basic steps and what we're all probably familiar with over many years of staff training was you have the division and the ESG. Okay, so that's the start of our building blocks. We have JSAF on the one side, driving our naval entities, and we have MTWAs on the other side with our Marine Corps entities. Well, in this case, for our training audience, that wasn't enough, right? They wanted more. They wanted to, like I said, this complex naval scenario. So we had to start building the puzzle. Okay, how are we going to represent joint air in our simulations? How about external Navy assets? Don't belong to the ESG, but they're going to be interacting with our forces in the game. Red ground, other Marine Corps assets that don't belong to the division. Red air, and finally, civilian maritime traffic, both maritime and aviation assets that might be flying through our airspace as we're conducting our near-peer engagements with our adversary. So it was our responsibility to kind of build this puzzle for the training audience and then translate that into a synthetic environment, not just with MTWAs and JSAF. How do we then stimulate CAC2S and FAST? How do we then translate that into C4I systems through TCS, C2BC, or FATIDS? And then, by the way, we're not just talking simulation traffic. Now we're talking Link 16 and JREEP-C, where I'm hooking tracks and I want a simulated entity to engage that J20 all through Link 16 traffic. So this was a kind of a big undertaking for us. So we took a step back and we said, hey, we better practice this stuff. We better try this thing in pretty much a benign lab environment. So we have all of these systems in an unclassified environment at the air station. So we started practicing our interactions, making sure that the entities were going to engage each other correctly. We then took those initial tests over to MCTISA. So MCTISA has a classified lab, AC2S, that we can use. And we repeated that again in a classified environment to test and pretty much proof of concept before we went into a CPX. So this was our plan, right? After months of testing, we had in our minds that this is how we were going to support the training audience. You have EWTG PAC on the left. They would be running JSAF through their JBus, connected to our MTWAs via HLA, where they interact naval and ground forces. The JBus also would push out Link 16 tracks to CA-C2S. I know it's a mouthful, but then also disk traffic to stimulate their raw radar feed. This is another one of those competing training requirements, right? The MAW in previous exercises, their air traffic control guys or their air command and control would get a radar track on their system that was already classified. So they would already know the answer to the test before they did their jobs. So they came to us and they said, hey, we want to see a raw radar track and then be able to classify that as a Hornet, a J-20, or a civilian airliner, and doing our job in this exercise. So we got to that by pushing that via disk, and then they would classify it, hook it, make it a link track, and push it out to the training audience. And then all of that information then would be fused at the tactical level on C4I systems and pushed to the training audience where then the commander could make decisions. Well, what happened? Life happened, right? So the Marine Corps didn't put in the proper requests for the network traffic coming across NCTE, and we end up running the exercise in two different spheres, right? The end state here, the good news is the training audience still got fantastic training. On our side behind the curtain, we were then swivel chairing, making sure that we were duplicating objects in the sims so that they would interact by having them federated in a true linked simulation fashion. So LVCTE in the future, what is our role? Why did I put this up here? For all the students out there, don't wait for the answers to be pushed to you by Headquarters Marine Corps or Big Navy, right? Go out there, try new things. This ICD, I circled it there, was 2010, right? We are now in 2022, and we're making very small incremental steps to getting to this vision. LVCTE program of record is happening though. This is all getting established in 29 Palms First next spring. We're super excited about it. We're super excited about how the MEF is going to use these new capabilities. The future is now, right? Nothing I talked about up here doesn't currently exist. We are here to facilitate training, try new things, and not be afraid to fail, because the place to fail is when you're training not in a live combat environment. And that's all I have. I filled up my 20 minutes.
Just a quick general question. I see a lot of capability with this. And I primarily don't look at training, but other opportunities for us to be able to use things operationally. Has anybody talked about over in that area about prototyping within that sort of environment? Prototyping in new systems, that sort of idea, that concept within the LVCTE?
Yeah, I don't know. That's not really my focus. Sorry.
Thank you.
I mean, but we do try new things. We have some technologies from ONR that we try as well. Our big thing is, since we're in a classified environment, we're all relying on ATO, ATC, right? And so you have to be cleared for a secret environment, and then we run our approvals through, I kind of breezed over it through NOC-TSD. So why we do what we can do is because we have a memorandum agreement with NAVAIR, NOC-TSD, to allow us to connect our systems to their aviation network. And so that really hamstrings us as far as what we can do as far as experimentation of new things.
Who within O&R?
Dr. Swire?
Okay. Thank you.
Yeah. Okay, thanks for your time. I'll be around all day if you have any more questions about this.
Excellent. We're really lucky because for those of you who know, we take a trip. The senior cohort is part of MD 4501, takes a trip to Southern California, and we go to National Training Center in Fort Irwin, 29 Palms. And this year, for the first time, we went to MCAS Pendleton, where another one of our 8825 graduates, Lieutenant Colonel, he's serving his second tour. It's not technically an 8825 billet, but it's a very strong M&S billet. Lieutenant Colonel Francis Pascucci invited us down. So we got to see a lot of this actually, what a little bit more than what you can see, in the presentation. So it's great stuff they're doing, and we're happy to have them. And so hopefully we'll be able to continue that in the future. So our next presenter is Mike York, retired Army Colonel. He's from Microsoft. He's going to be briefing on the 21st century gaming experimentation, modeling, and simulation project, or GEMS is what we just call it. So, Mike.
Yeah, so the beauty of this is the fact that we're behind and Perry's running a very tight ship, no pun intended. I'll be able to skip a lot of this because the first couple of days, you guys already hit on this. But to set the stage, yeah, I am an MPS alum, even though I'm Army. Matter of fact, I went to the War College as well, so everybody claims me as, hey, you went to 2 Navy schools as an Army guy. I say, hey, I got lucky. We had to teach Navy guys that ships supports joint fires. So there's 2 points I'm gonna hit, and most of it I'll be able to blow through because the point of this is to talk about part of the CRETA and then look at how Microsoft saw the need and addressed the need. So we'll skip the need slides. That was the first point of taking some of the commercial capabilities from the gaming ecosystem and applying it to the federal space. So when you're in Microsoft, you hear a big company, but some do not know inside of Microsoft, there's a separate business unit that is directly focused on now in the last 2 years on the federal problem set. That's just DOD, it's IC, it's Justice, it's FEMA, it's Homeland Security. Because the problem sets inside federal have unique requirements that you all know that is not the same as commercial, but there are potential applications. So 2 theories and a hypothesis. We'll blow by the needs because you all get it. Because after hearing the first 2 days, you all get the need as to why, and I don't want to preach to the choir, but then show and hypothesize how that same technology stack and ecosystem can potentially be applied to the problems that we're facing on the DoD side. So of course, let's set the stage a little bit. A little humor, as they say. Yeah, I'm an Army guy, so there will be lots of pictures, lots of videos. So Marines, we can wave at each other. There is an obligatory ship for the Navy guys. Oh, I say boat because I think there's a sub guy in here somewhere. And there is a plane, there's some aircraft for the Air Force, so you can wave. And there is a satellite if any Guardians are listening or jumped in as well. So I covered all the services, except for Coast Guard. I know you're out there too. But there also is a legal disclaimer I have to give. I don't own the rights to the videos of some of the images and pictures because one of the pictures is of MPS and some students. So I'll blow through that. But please, any characters expressed or implied, I'm the sole proprietor for that. So the big thing is GEMS. What is it? Earlier, Emra at the opening, if you weren't here, introduced the MPS CRETA, and you just heard about how CRETAs work. Inside of Microsoft, and I think we've been working on this for about 3 years, excuse me. So someone asked, how long does it take to do a CRETA? We're not the best use case. I didn't say the best use case. It was a deliberate process that took 3 years to do because it was that important and an investment from the Microsoft side to do it. These 4 projects up here, each individual one, I'm only going to focus on number 3 and talk about why we went into that project to potentially help support pack fleet and delivery from here. Each project has a principal investigator from MPS paired with a representative from Microsoft to look at different topics and applications across. So if you hadn't heard about that on the campus, Emma is one of the principal investigators. So for P3, so he gets to go under the hood a lot more than he probably likes occasionally with the team. As we're building out an initial prototype to answer one of pack fleet's problem sets potentially. This is all brand new, just announced officially in May. So if you're on the campus, there's a few principal investigators running around that kind of have the the eye on this, and I think it's Colonel Pugh has the overarching run on this. So Captain Select, that's right. Yes, sir. Captain Select. Congratulations. Okay, so won't get into details of each one of those. This was the need as to why, which most of you guys get. So I'm not going to read through this, but the bottom line is the community had been asking for this even before. Are some of you familiar with the Defense Science Board, January 2021? If you're in the community, you probably read it, saying, hey, we need to do gyms more to do better, everything. Acquisition to readiness, to long-range planning, to government strategy. Great. But most of you in this community and those before this were asking for this kind of stuff before and bringing technology up to speed to address, be it, call it wargaming, call it serious gaming, but basically better tools to enable that marriage between the human intuition with some of the art and, the art and science marriage that needs to exist to inform decisions, to identify risks, to generate new ideas or alternate COAs for most of the military planners. So I'll blow through this to save time, but you guys can read that. So I'm not going to read the slide to you. The next piece is the picture I was going to show. We still do this, don't we, today? Most of the Mod 10 folks in here go, wait a minute, we can do this better, right? But some of this has its own applications. Some of this they still be useful, but there's a way to add technology to do it. But the quote I liked at the bottom of this was, technology has advanced, but it still has a human component of decision making. It's not all going to be pure ones and zeros because AI and ML. So I'm an operator, so yeah, we'll trust the machines, but there's still a human dimension of choosing and evaluating the risk. And sometimes the computer may come up with a COA, but my gut sense may say, hey, I'm gonna do something different. That's okay. This part, how many people recognize some of these games if you ever went through a military professional education? Strategy games. They were contained in a box, in a room, on a certain computer, in a certain lab. You had to schedule time. And this is what we were teaching or are teaching some of our future leaders on. I would give this example of 21st century gems. In our view was we got approached with a problem set. How do I make it available for any player, we'll say student, won't name the place, but any student to access and run their scenario and strategy planning session, which is required as part of their education, any place, anytime, and on any device. That was a unique problem set. Right now in the demo, and you see Command PE up there, and if anybody went to modern day Marine, in the first demo use case, we were unable to make it available for Command PE and other strategy games that are usually confined to a set room to be played on an iPad or played through the cloud, digitized and available. So now it's no longer, it takes me a day to get 5 students into one room to play Command PE to get my output. Now they can play it at the time they need to do it. That's the next step. But the real question is, can we do better? And that's what everybody wants. So what I want to do is play a little imagine if for you here. Hopefully the sound is up. I don't think the sound's going through, Barry. That's okay. You guys will get it. Some have been around and seen this video before. Yeah, the thematic music's not playing. Let's see here. Can't hear the thematic music. It'll be okay. Yeah, the music's better, but So the point of that is, yeah, that looks like a cheesy, Hollywood video if you want to take it that way. But that stage right now is not that far off. And I've overlaid a couple of snap blocks here, if you can see them, and identified a couple of areas. And that's part two of the point of this was, can we leverage the ecosystem that's been used from the gaming side of the house and commercial to address the DoD federal space problem set or national security? So what we're talking about with the GEMs and bringing researchers, bringing subject matter experts from the field to put them in an environment where they can test and do some of that. Let's do a couple of check blocks. AI-driven units, decision-making, red team. Check. We kind of got that today. You got synthetic environments. You've heard from some of the other companies in here. Check. We got that today. We've got spatial terrain. Check, check, check. We've got these kind of things, but the problem is that most of you have expressed is they're in either stovepipes positions. They're not necessarily brought together. Common standards is a problem, but how do we work better to get, to do more with that? And, Verity made the comment I already told him yesterday. He said one ring to rule them all from the Lord of the Rings kind of thing. No, there isn't one ring to rule them all. The question is, how do you synthesize some of those things together and evolve the technology, the new technology to build the next thing, to make it available for the future users. So this is a slide I love to show because everybody goes, you're Microsoft, and I'll give the disclaimer now. If you're here because you think you're going to get insights on an Xbox for Christmas for your kids, you can leave now. If you're here thinking I'm going to let you play with a HoloLens too, you can leave now. So we're all still here. Good. That is not why we're here. And nor is it about these titles and games. The thing about this is that some people miss between the gaming side of the house that Xbox has done for 40 plus years is it's not just the titles and how well they sell. It's the technology underneath them that have enabled them. Minecraft, best-selling game there is, 140 million active users a month. Yeah, there's some numbers in here for the computer science guys too, I forgot. So it's really, when you think about that game in and of itself, is pretty much a distributed simulation game that's always on. Dispersed, scale, you can create in the game another piece of the game by the swing of an axe. That's infinite hyperscale infrastructure. Sounds familiar? Something we need live virtual perspective. Just an example. Let's look at Forza. It's not just a car game. How many racers we got out here? Who likes race cars? I'm sorry, I watch NASCAR. This thing right here underneath the hood of Forza is a AI vehicle that has 1,000 tunable parameters. Just one car. And the thing about it is, it learns how other drivers drive across the world that play the game to improve its play against your contestant. AI learning, imagine that during training exercises and playing, and other simulations. Halo, I won't get to Halo, love Halo. HUDs, everybody's seen those. I mean, next generation scenarios, AI bot matching, creating user-based scenarios within the game. Why can't we use that on the other side of the street? This is what I wanted to talk about. The big one I want to pull the thread on, or two, is we'll go back to the digital twins and flight sim. There's a lot of aviators in here. I'm sure folks are familiar with flight sim. Forza. Inside the AI drivers that are in the game, it gives you the ability to create a driver car. What does it mean? It uses lap data from players all over the world, including your own, and I'll get to that last bit, to figure out line tracing, line following, all of that to offer predictive behaviors, aggressiveness, how hard you brake, how fast you drive, and creates an avatar to race against. That same AI model potentially can pull your data where you can create a replication of your driving set and your friends can race you offline. It's not about the games, what's under the hood. How can we use that type of model and human behavior learning to apply it on our side of the fence? It's in the game. Why can't it be on this side? Flight sim. I love this one. Pilots in here again? How many of you know flight sim? Got a few. This one has over 30. I got to look at my numbers because I'm not the guy. Literally, I got all this from the commercial side of the house. So I'm like, why can't we do this on the other side? 37,000 airports, 1.5 million buildings, 2 trillion other assets in this game alone. Roads, trees, and all that other stuff. But that's static. How they improved it, and I'll show you a video later on to see the last one that was just released, was they brought in live data to give you traffic, putting in data about animal patterns and migration to make the world feel real. So when you fly from Monterey Airport, down south in the game, it looks the exact same way if you did it for real. People are training on this thing. News to me. So when you look at those games and then you pull up the hood, how can we use some of those same capabilities or potential technologies that drive these wonderful entertainment things to solve our problem set in the federal space? So of course, like I said, I'll get to why these things are in common. We all need this to create those environments you want. Got it. That's the common stack. So let's pull it all over and say, how do I deal with that common stack? Because everybody goes, great, you're a big ass company, Microsoft, excuse my language. You're a big company, Microsoft. You got, you can handle all that. Well, during COVID, we'll give you a use case of Microsoft. Put on under the hood. Then to deal with the growth that occurred during the pandemic. Remember, our product has got to be always on 24/7. It has to deliver low latency. It has to meet the needs of the users and give them an experience, or they won't buy it or use it. This is just one thing. Oh, by the way, you got to secure it. All those things Mod Sim and commanders want when they play their game. How do I secure my stuff? How do I make sure it's ready? And how do I play? So that's why I'm revealing some of the under the hood stuff. And here's the other part. I did not know this, and I had to do research and ask one of the guys, because the first question is, what do you do with all that data? And you can't handle all my data. I'm federal. I got a lot of data. This is zettabytes. One rack and one data center. Great. That's a lot of data we can store, but we got multiple data centers. So just multiply that. How do you get it to the user? Building off the same ecosystem that we already have for the gaming side, now applying that to the federal problem set. Multiple data centers that can hold that data and move it to deliver low latency. Isn't that what DoD needs for live constructive? We're not the solution, but there's other partners in this. And the piece that's not shown is we've made investments in the space side of the house. Do cloud analytics for SAR, multi-int, it's out there. How do we bring other partners into play to do that? And that's Jim to the 21st century. Money where our mouth is. This is why I partner with the NPS side of the house to go, we've made investments. How do we leverage that investment to solve part of that problem? We didn't grow just for our own growth's sake. We had to handle it for Xbox. Xbox is going to allow. It's using that network. But we've also invested on the Gov side. Gov classified up to TS. So how do we bring that problem set that has classified data issues into the right space to give you a safe place to do this? Because I'm running short. If you don't know about AirSim, this is one that's out there for all you mod sims. This is out on the net now. You can use it. It's robotic AI training. It's in the cloud. I'll skip that one, but I'll show you later if you want. The real meat is this. Some of you are interested when you saw this. This is a proof of concept. We're making this available in the cloud for others to use. Leveraging the partners, SIs, the other AI and ML solutions that are out there, bringing together some of the best to provide it to solve the problems. Again, it's only a taste because this was the initial beginning. The real meat is this on the other side of that. What happens, and this is flight sim, where you bring the great technology, Maxar, Black Shark, and others to create that world and that realism that is needed that most of us want. Let's see if this plays. And you can't hear the sound. It's better on the screen. It's like the reminders of Memorex. When you see it on another screen, it's crazy. Here's the walkway. There's not one ring through them all, but the NPS created and the opportunity to bring guys that are doing near research now, students, and bringing industry closer to some of the new technology. How do we build out that next construct to offer a framework? Not the solution itself, but the framework, the floor, come up with some standards to build the framework for others to come into. That's why the opportunity to do this took 3 years, is like work through the details of what is the community, the Navy, DoD going to get out of that opportunity when you bring the technology a little closer to the user and the problem set. So this is our view on 21st Century Jones. And the one that's out there that I'll address in the last 30 seconds is, yeah, this is all new technology. Some of this stuff is already there. There's other things coming. And then of course we hear that word that's dangerous, metaverse. Let me give you my opinion. There's one metaverse, just like there's one internet. That way it keeps it simple for me in my mind. Everybody's got their name for it. But from the Microsoft perspective, from live virtual constructive, we are investing to bring that together going forward. The piece you may not have seen is we've stood up, you saw the 26 plus studios. We've stood up a serious gaming studio specifically to address part of that problem set for the federal business. I will bring that same component piece to address the unique problems, be it FEMA, Homeland Security, and others. That's all I've got.
Okay, thank you very much to everyone who stuck it out. This is our last presentation session, and we've got some really good ones. We scheduled them here to try to keep everybody around, so hopefully we'll be ready to go. Right now we have Dr. Richard Webb of, I don't know, Designory or Designery, okay, of Designery. He's going to be talking about, extended reality, extending intelligence, and enterprise agility. I think it's a pretty interesting talk. I've looked through his slides, so I'm looking forward to it. So, Richard, take it away.
All right. And thank you for inviting me to come. Actually, it was Glenn Hodges.
If you're gonna wonder.
Okay, well, I can resist the attempt. I usually walk, but
We can put this on too if you want.
yeah. Why don't we do that? I'm a Paramedic School of Education. Okay, can you hear me now? All right, excellent. Okay, again, my name's Richard Webb, Dr. Webb. In 2019, I was running the Innovative Design Studio at the University of Alaska, Anchorage. And the purpose of the studio was to explore emerging technologies and to see how those technologies might be able to interface with the university and provide an engaging and effective learning experience for our students. Of those technologies, the reality spectrum, virtual reality, augmented reality, those were the ones that were really showed a lot of interest in. We are a public-facing university, and so we had a lot of folks coming in from the public. And one of the questions, we'd show them, all the wares that we have, and the question they had over and over again was, who in Alaska does this? And the answer was no one. So again, 2019, I was sitting in my office and like Colonel Verde and his daughter, my daughter Emily and I are huge LOTR fans. And so I thought to myself, I think it's time for a new adventure. So that adventure was to start a small business that was going to look into virtual reality, and as a small business was going to survive in a small business environment. I wasn't looking for a lot of investment, use the money to survive. I was going to go out, start a small business. It had to prove itself to be effective, and it had to prove that it could survive in a small business environment. My talk here addresses the three critical areas that looks at. Extended reality, that's the VR, et cetera, and I'll get into that in a second. Extending intelligence, how do we provide students with an engaging learning experience? And then enterprise agility, that's small business. So let's start with extended reality. Okay. Now this is, there's going to be a number of videos because I want to kind of give you the experience of going inside the headset.
Hi, my name is Matt. In this video, I'd like to provide some insight as to how Designery and DOT training solutions are working together to revolutionize commercial vehicle enforcement roadside inspection training using virtual reality technology. In this demo roadside inspection app created for the Florida Highway Patrol, users interface with a virtual reality head-mounted display connected to Wi-Fi to log in, perform an inspection, and receive immediate performance feedback. Based upon the Commercial Vehicle Safety Alliance's 10-step checklist for performing roadside inspections, our training app recreates a typical commercial vehicle stop and inspection to the highest fidelity, all while creating intuitive interfaces and minimizing those which would inhibit learning. The user begins by reviewing the shipping paper associated with the vehicle and materials transported. The inspection report is designed to interface the same as a typical tablet, which users can open via a flyout tool menu. Tools may be implemented as appropriate, but here you can see the user has access to the tablet and flashlight.
And that's a fully functional.
Part of the CVSA inspection includes referencing 49 CFR section 172-101, appendices A and B, to check whether the materials in transport are hazardous materials and/or marine pollutants. We've provided access to the appendices by an interactive pop-up window.
That's the inspection plate. It's where everything begins. And if you notice, as you move in, it comes into view. What we're trying to do is the real experience of the trooper, we're trying to duplicate that.
As the user proceeds through the inspection checklist form, he or she must navigate the virtual environment to check the pertinent vehicle components, such as placarding, specification plate, inspection test date markings, double bulkhead drains, shear sections, piping, valves, and emergency flow control devices, along with other protections.
Now, one of the things that's important to understand here is the person actually has to get down, crawl under.
Any of these inspection items included in the checklist may be designed to have a defect attributed at a random interval, meaning that each time the application is restarted, a new combination of defective items is attributed. This ensures that the training may not be gamed and can be equally as valuable every time the user goes through it.
And again, they're underneath there. They're having the full experience. And they have the headset on. So you're seeing what this was recorded inside.
Each of the checkboxes indicates a threshold at which the user must enter an input based upon their observations, which is measured against the current state of the vehicle. These inputs can gauge the user's decision-making when performing the inspections and can afford valuable insight as to when and where a trainee has failed to recognize an issue.
And all of that data can be collected by the instructor, and then they can look at where things stand, where the areas are that are, problems are occurring, and on an individual student basis. And again, as I said,
While this inspection
operation
subject is a DOT 406 tanker, the inspection form can accommodate any commercial vehicle or package were the assets to be built.
and so then at the end, you can look at what was your answer, you get feedback on it. But as I said, the instructor sees all of this as well. So for me, that's as a instructor, I love the fact that I can look at students as individuals and modify their training appropriately. There you can see some of the other various hazards they go through. Each time they go through it, it's
Serving content and iterative application versions is managed through an online device and content management platform.
okay. In the interest of time, now this is about 2 or 3 more minutes long, but I'll condense it. What we have is you put the headset on. The headset has a unique identifier. Each student in it is an encrypted identifier. You put those together, and now I can track that student with that headset. As soon as the student takes the headset off, we do a lot with educational institutions, so it has to be FERPA compliant. Everything is erased from it. So each time you put it on, it's sent to your phone. There's a 4 or 6 digit code put in, and now we've tied the headset to the student so that you can have a limited number of headsets and an unlimited number of students. All right, real quick. When we talk about virtual reality, what we tend to not understand is this is actually a large number of modalities. Screened reality. You know, if you have a teenage son or daughter, or most of us these days, screened reality is something like your phone. We interact with that. That's become a major part of a reality. Enclosed reality. Those were our early attempts to kind of put ourselves in spaces. We still do. Flight simulators are a good example. But when I was much younger and a gamer, I used to take 3 computer screens. I'd have 1 in front of me and 2 inside of me, and I'd try and get that experience. Immersed reality. I'm about to show you some immersed reality. The idea behind that is that it's a fully, it's a 360 photograph, high definition. We can go as high as 11K, and the experience that you're having is that photographic experience. We don't have to do any programming, and I'll show you that in a second. Layered reality is when we add hotspots to it so that you can do things with it. Then you hit the virtual reality, and I think eventually augmented reality is going to rule the world because it can move from one space to another. And all together, for those of you who are not familiar with it, XR is kind of like the cover term. Okay, I won't show you this entire video this is that this is a cod fishing vessel in Seattle, and the client that we
Welcome aboard the Flicka. As part of your orientation, please navigate the vessel and locate the following. Hints can be provided by clicking the icons to the left of each item. Click the stop sign to end your search. Your time and scoring starts now.
The captain's seat is located on the bridge.
Our client wanted
The observer berth is located next to the captain and mate berths.
so you know where everything is on board the ship.
The hauling station is located on the starboard side of the main deck.
Go around and they'll explore it. And again, you can put a headset on them and they're literally going around and exploring. The beauty of this is that it's very low cost. And then you can see there the various safety devices, but we can also expand that out and have them do pop-ups on it as well. And the reason they have to find the captain's seat, captain's chair, you'll see in a second, is because there's and you can see how it highlights there, but there you have it. the emergency distress radio. So everybody knows where that is. I'm going to go ahead and move. Move a bit further forward here. Okay. And so again, they're going through the entire ship. There are about 113 items on here that they would have to find. And that's the schematic drawings of all the decks. And that's where all the locations are. So they can also not only learn it by experiencing it, they can learn it off a map, which is a pretty standard way for humans to navigate. And then you can see you can score it. In this case, it was very quick, but you can see how many they've gone through. All right, let's.
Please navigate the vessel and locate the following. Hints can be provided by clicking the.
All right, what happened here? There we go. As I explored this, I began to understand that this is not one technology. It's not the VR is not a technology. It's a spectrum of technology. And I began to realize that it's very similar to the electromagnetic spectrum. In fact, this spectrum has revolutionized our world. Ever since Faraday's electromagnetic experiment, where he discovered that electricity and magnetism were the same thing. And you can see all the different technologies that we have in this, all the way from radio waves on through. What if we were to imagine that the reality spectrum was similar? All the way over here, we have something called lived reality, and that's my holy grail. The first thing we do with our clients, we go in, we look at and we share their experience. Like, what is it to be this person in this environment? And we'll often spend days with them gaining that experience. At the same time, we're capturing reality. We capture it with high definition photography, with LiDAR scanning. We then map their workflows. We want to look and see what are all the things they're doing. Then we model it. We both with 3D models, but also modeling in terms of how can we make improvements. Played reality. I believe that play is the native language of human learning. This particular thing is usually using a game engine, whether it's Unity 3D or the Unreal Engine. Then we get into the really interesting stuff, the quantified self. I, as an instructor, can take, the student is in the program, I can take out all sorts of information. I can collate that data. I can bundle it. I can look at students in terms of group. I can look at them in terms of their individuality. I can also look at the test. Is the test actually doing what it says it's doing? And then I call it storied reality in deference to Dr. Patrick Wilson of MIT, where he believed that artificial intelligence, the ultimate goal of AI was to be able to tell stories. And again, here you can see where we're mapping this, it's going from increasing physicality in that direction to increasing virtuality in this direction. And then that model part, you can see where we can actually start looking at the technology itself and develop studies, develop models to predict where it is we are and where we want to go. All right, I'm going to play. How much time do I have here?
My name is Thomas.
I'm a
Webb,
recovering
and I'm the
academic.
creative
I'm
director
sorry.
and
20
designer.
minutes is just getting started.
I'm here today to talk to you about our normal production cycle and show you.
I want to show you with 3 minutes. Oh, this is an interesting one you might find. Did I narrate this? This is at a in Pennsylvania. I forget what they're called, where they have to have all this equipment ready to go. And it's, but here you can see we did the LiDAR scanning. We went through the entire facility and we spent a whole week there with them. And there's going to be, in just a second, you'll see. Okay. You can see there the measuring. We did this with a Leica BLK 360 a camera, a LiDAR instrument, and at 60 meters out, it's accurate to 6 millimeters. So when we create this environment, we create the environment that they're moving around in. You saw at the beginning where you have to crawl under and so forth. That environment is millimeter, and in fact, close up sub-millimeter accurate, so that you can do incredibly detailed. Let me see. So maybe I'll finish up with this one, but only getting started. This was training for asthma.
Hi, my name is Matt, and in this video, I'd like to demonstrate how Designery and the Alaska Maritime Training Center at AvTech are working together to develop a virtual reality tug operations training application.
Again, all the instruments on board there are accurate. They're displaying accurate.
While development of this training app is still ongoing, I wanted to showcase some of the current functionalities that we've developed so far. The setting of this app is a digital reproduction of Dutch Harbor based on procedurally generated terrain from height map data. We've also modeled a port and berths to accommodate a few vessels. Environmental physics such as wind, buoyancy, and fluid resistance are all tuned to the highest realism to affect vessel performance and behavior.
Again, we want to capture the lived reality.
The bridge of the tug has several functional instruments and controls available to the user, including azimuth drive thruster controls, an azimuth counting display, tug Doppler, bathymetry chart plotter, and manual winch controls. From here, the user can maneuver the tug, connect and disconnect hawser lines, and make use of realistic information from the instruments.
There we go. Oh, here I wanted to show real quick about there's the lived reality, but you can see, and for example, the scale right there is an accurate scale. It's weighing it. All the physics of this are completely accurate. So since I'm out of time, let me go all the way to the end here. I should be able to run through this super quick. Ford, right? We all know the story of Ford and the huge River Rouge plant and Rouge River plant. He got his start, interestingly enough. He failed several times in car companies, and he really kind of bit into it when he he did racing. The interesting thing about that is I compare that to gamers today. That's the Model T, revolutionized our world. You can see here, price is coming down. This is the actual price at the time. This would be the cost today. Continuously reducing the price. But, and here's the part of the story that you don't hear about. What happened surrounding the Model T? This was the reality when the Model T was first introduced, right? And so what do you have to do? You have to start changing that. You have to start creating roads. You can't go very far without gasoline. All of a sudden, thousands, tens of thousands of small businesses are popping up that are supporting that automobile. Pretty soon, businesses are starting to utilize this technology to be able to do things that they couldn't do before or do it better. I love this one. A whole company developed where you could turn your Model T into an actual tractor. Our education began to change. We changed from that to this, to the CTE world developed then. So the argument I'm making is that just like Ford and the automobile, we have the large companies who are creating the VR and AR instruments and technology, but it's going to be that the dispersion of small business throughout that will be supporting this. And these are the lessons that I learned over the course of the last 3 years. By the way, we have grown so fast, and we just can't keep up at this point. We're almost at the point of deciding, like, what does it mean to be a small business? But here are the lessons. Know your destination. I believe in the military. Okay, sorry.
It's a little too long, but
all right.
These are great lessons. That was a great analogy about Henry Ford. So I appreciate it. You're going to be at the demo this afternoon?
Sure.
Yeah, so I think a lot of these videos you can watch in full detail there. So
if you go to XREI.designery.net, there's a ton of videos.
Excellent.
Okay.
Well, thank you very much, Richard. Okay, our next presenters are Mr. Pritesh Patel, the founder and CEO of Ad Hoc Research, and our own Moves graduate, Lieutenant Colonel Bill Platt, who's retired from the Army. They're going to be down here and talking about all the great work that Ad Hoc is doing. So, oops, I haven't shared your slides yet. One second. Let me do that.
So I kept Perry up a little late last night, and this slide is a little different slide deck based on the whole week's topic of conversation. So interesting discussion yesterday about, and sort of across DoD, anytime you mention cyber EW, what happens? Especially in a modeling and simulation world, what normally happens? Very nice. What other things happen? Different databases, right? Throwing effects. So anyway, I want to introduce my CEO and founder of Ad Hoc. Pritesh and I met about 2016, I guess, for the first time. We followed back up in industry. I was with Matova running PCTE, Kick 1 and Kick 2. That's where's Danny at? Did he leave? So anyway, great job, Danny. Really strong work. And so this idea, as Pritesh and I were talking, he's describing an environment. Like, how do you draw a rich picture and a narrative of the network? And I'm not talking about just the network of the tactical network, but how does the tactical fit into the operational? How does the operational affect the strategic? And then how do you add behaviors and characteristics and deploy it inside an operational environment? OneSAP, NRL Builder, eMain, WarSim, right? Those are all program of record systems. Well, Pritesh built a Modesta, and it's modeling, emulation, simulation, test and analysis, 1,500 entity level baseline at the BCT and below for NIE. Raise your hand if you remember NIE. So, okay, good. So NIE stands for Network Integration Evaluation. It was the Army's terminology to bring in COTS, integrate them in the GOTS with the mission command systems, and then deploy those to real world, right? Afghanistan, Iraq, and see how that worked. Well, that was the first widget. That was the first digital twinning of that network, that operational network, before they hit the live environment to say, yes, this is good for soldiers, sailors, airmen, and Marines. So Pritesh built this 1,500 entity that extended that network in a modeling and simulation emulation environment. But not only that, it added the RF propagation behaviors and characteristics of the specific systems. So you're raising the fidelity of what that looks like for MDO, for JADC2. How do you integrate? How do you fall in? How do you extend your network? How do you get the 5G, 4G And in the Army, the joke as a signal officer is we're at 256 kilobits per second at the tactical edge, and the commander gets to have one email. Right? It's not funny, but that's exactly where we're at today still. So how do you build this model? How do you get into cyber, EW, draw a rich picture and a narrative of your concept and capability development? So sort of in a nutshell, what happened with NIE is it went away and changed into JWA, right? Everybody tracking that? That's the joint thing. And they're like, hey, all these systems, we're not just concerned about Army, although we love the Army, we're concerned about this joint space. And what happens when you go from Army to joint? Does it flatline with limitations and capabilities? It's exponential. So we're currently supporting that effort as well. So a little bit of background about myself. I was a signal officer for 8 years. The Army gave up all their signal brigade commander slots. And I was like, okay, I can either get out or go pick a functional area. So got accepted to Naval Postgraduate School by the grace of God only. You know, my claim to fame while I was here is I made John Falvey drop the F-bomb in C++ class day 3. So I don't think John's here anymore, but it was good training, but a lot of good stuff. So Perry, Rudy, Eric, really good to see everybody. So I did this modeling and simulation master's degree program. First year was painful, right? But iron sharpens iron. That's what I tell every single person in here that's going through MOVE's program. If it doesn't suck, you're not learning, period. It just doesn't. You're not going to learn if it doesn't suck. And I mean, work hard, like 18, 20 hours a day. So that's how you become better. So I left here, went to 2ID, integrated war sim for the first time in a division level warfighter exercise. So there's this integration interoperability challenge. And who's familiar with war sim at the aggregate level? I said aggregate level because there's no high fidelity within war sim to display anything cyber, EW, network analysis, anything like that. So it's a staff trainer. And I kept saying, hey, how are we going to replicate the networks? How are we going to actually show causation and effect throughout the environment to inform capabilities and training objectives? Pretty interesting. Very interesting. All right, next slide, please. All right, so here we are. We don't ever want to sort of be the sales guys up front, but proof is in the pudding. We like to be first. We like to be fast, and we like to be in the top 123 fastest growing small business companies in the nation. So that's good. But we continue to win, not because of sort of luck and we know the right people. It's because we work hard and we focus on warfighter challenges and at the very most complex level. And that is cyber EW, 100%. So this whole MDO stuff, as you all know, I wrote the ICD for the initial MDO integration into the Army. It was the only addition was cyberspace and electronic warfare, space, and now it's information operations going into information advantage. And if you don't understand that, then you don't really understand the premise that everything has to start with a network. Has to start with a network. You have to replicate the network at all levels, at all echelons, going into wherever you are. Train as you fight, but build it before you go there because you don't know all the capabilities and limitations of the network that you're going to be operationalizing. So where are we? Army Cyber Battle Lab. Raise your hand if you're familiar with the Army Cyber Battle Lab. Prototype experimentation, CyberQuest, the only Army level prototype assessment that we do using COTS, commercial off-the-shelf technologies. We embed those into WinT Army network, and then we do the evaluation of how you operationally deploy. So think live environment. You have EW sensors, EW PMT, you have PTIDs, tactical relay towers, back to the TOC, into a BCT TOC, over to the modeling and simulation OneSAF wraparound, because OneSAF has a challenge doing cyber and EW. We know that. Okay, we're gonna help you fix it. But then you have this idea of how does that inform capabilities and concepts for future science and technology investments for the future, like real world warfighter stuff. Like how do you employ it? What is the what if? How many times do we run an experiment in the Army? And I'm Army, so I'm sort of telling on myself, I used to run all the experimentation out of the Cyber Battle Lab. And I wish Quinn Kennedy was here. Once. We run it once and call it an experiment. Huh? Wow. Okay. All right, that's okay. But you have to create this environment by which you can run it many times and reuse the data many times. And that's what we're talking about that we're helping Cyber Battle Lab get to, is the idea of digital twinning the network and networks and devices, and then conducting analytics within the same framework. Because what also happens is even if you have a really cool Cyber EW tool, what it doesn't do is data analytics on the back end of that, using machine learning algorithms, things of that nature. Let me hit NCRC. NCRC, National Cyber Range Complex, that's a joint challenge. That's cyber hardening of all our weapon systems platforms. For the discussion yesterday, you know, it's interesting, right? GPS is a problem. 1553 CAN buses that run all the weapon systems, a problem. So I was with BAE Systems. We actually did a live environment test for an EW jam on a 1553. Not good. So real world stuff. So we're excited about that this year. AT&T. It's interesting. We got a project with AT&T. They actually approached us about how do you improve our predictive analytics for their data ops program, their data science office. And so they hired us to do one project, and in the last 6 months, we've grown that to 5 projects. And the analysis that we just received from AT&T is we literally are saving them $8 million a year, because we are building their ML ops and their AI framework for their data ML stuff faster, better than they could. And quite frankly, it was too expensive for them to do it internally. So they hired us. So we're excited about that. MDOC-5I, Marines, raise your hand. Yeah, phenomenal, right? Phenomenal. Thanks for your service. It's really good. So 29 palms. How do you digital twin PCAP data? How do you take PCAP data, pull it from T-Shark and Wireshark, and then align that with what's normal, not normal, abnormal, tie it to a device, and then do port analytics on the fly, live and digital twin. So that's sort of, without taking the whole time to describe that, well, if you're interested in that, I'd love to tell you about it. Army C5 ISR, JSIL. We talked a lot about JSIL in the CSIL labs, right? Integration, R&D stuff. So we're right in the middle of that. So that's the cradle question I asked this morning. I want to do a cradle with MPS and quite frankly everywhere, because I want to build a community, right? You know, this is not a sales pitch. I'm interested in warfighting and helping warfighters, and then informing thesis research to go after all joint challenges. And quite frankly, without digital twinning it, it makes it tough. All right, NetCom. NetCom's interesting. If you're not familiar with NetCom, they fall up under our cyber. They're looking at the network, and so a question that we recently just asked them is, okay, show me an OV1 OS1 of your future network. Okay, all right, good. All right, enough of that. So this idea of working with MPS, you know, bringing our technology in, but also looking at what if across the space. And that's you know, I've never pretended to be a Navy person, but we value that. We think we have the capability that would be valuable to this organization. And quite frankly, I want to give back, and Pritesh has allowed me to give back. So we're looking forward to something, a partnership. All right, so Project Convergence. Who's involved or knows about Project Convergence? Okay, so let me just a quick story. So just so you're tracking about Project Convergence, at Aberdeen Proving Ground, They have accepted 256 technologies to help them do experimentation for Project Convergence. I don't say that as an industry guy. I say that as Bill Platt and a modeling and simulation officer that goes, man, that's going to be tough to manage 20. So how are you doing your baseline, and then how you measure when who comes in and what they do and how they help inform requirements and decisions. So we're super excited to be a part of the solution. But the part of the solution is if you're not able to digital twin a network, and then you're not able to show cyber and EW effects on that network and how you react and then a counteraction to that network, it makes it extremely challenging. Let's see. Marcel, everybody's familiar with ITSIC, Advanced Navy Cyber Training. Interesting about the Navy, you know, some of their advanced cyber training folks, they're limited by their network off of the neck, which is interesting because we wanted to take them to AWS because we're an AWS partner for scalability and shareability across the entire Navy. So it's nice that the advanced cyber warfighter folks will hopefully gain some better training, but I really want them to share their lessons learned and build their own entire networks and then do baseline training across the Navy. And so they're not there yet, but that's the intent of that if that decision is made. TREX, Training Readiness Accelerator. If you're not familiar with that, please get familiar with that. It's not a TREX brief, but really good way of industry connecting through OTAs and going after work without having to go through the RMF and RFP process. It's pretty brutal, makes it nice. The young ladies down there are fantastic. Vulcan Consortium, we just got accepted for the SITS conference, the Synthetic Internet training. We're briefing our IO platform. So we're crawling Russia propaganda websites, China, North Korea, whatever open source, public facing websites you want to. We're tying those to Twitter, and then we're doing analysis. So that would be for the live. That's the Mackay folks at the Marine Corps who are like warfighting real world right now. But really there's this idea in my own mind that I'm trying to impart, and then you add your own scenarios for your particular training objectives. So why don't we crowdsource that as a community? We know we need it, right? It's an IO platform. We have the smartest, soldiers, sailors, airmen, Marines in the world right now, very technologically advanced, much smarter than I was when I joined in '93. Why don't we hand it to soldiers and let them crowdsource it? So, universities such as this, the organizations such as MPS, West Point, ACI, Naval Academy, I don't know, just thinking out loud. And then this idea of going right to the PEOs. And I love that we had a bunch of my brothers, Fatty B. Betts and I were classmates. We met a long time ago at Georgia Tech, but one of the interesting things that we had a discussion, and it continues to be a discussion because the money doesn't flow unless there's a requirement and a signal demand, right? But who's writing the requirements? This is some of my frustration. Probably why I retired, not to get too personal, but probably why I retired. Because the requirements say what? And we want some LVCIA integrated training environment with a little bit of this and a little bit of that. So that's great. To do what? Give me 5 tasks you want done by the soldiers right now that you want to employ to do LVC. Oh, well, expand the training environment. Great, that's good. What's another one? We want to tie in the FLOT folks moving across with the deep fight and the deep fires, JDOCs, FATIDs. We want to kind of take a look at that picture for Korea as an example. That's good. So why doesn't your requirement have it? It's unbelievable. Like your requirements can't be at the top level. It has to be like, no kidding. Objective number 1 is to, right? Make it military, because that's what we are. All right, next slide. Yeah, thank you. Okay, so here's just right there, dark stacks. That'd be good. Yeah, perfect. So digital twin. So it was great because he's not here, but he asked me a question. What do you mean by digital twin? It's digital twin, like digital twin, the real world environment, like an avionics system, a weapon systems platform. And there's different ways of making models of that, right? You can look in the manual and you can kind of do hand jam, that you can virtualize it, you can containerize it. And then you can do machine learning algorithms and add cognitive agents to it to do something, right? And that's where the fidelity comes in, but that's how we ad hoc get to the analytics piece, because it's a decision maker giving you information back into your own framework. So you're creating digital twins in all sorts of different areas, MDO, let's call it, but you're also doing data analytics and machine learning algorithms, visualizing the data, copy pasting the URL and sending it to your commander. Did you see that full string? That's what a knowledge manager is looking for. That's what the leaders are looking for, because it's then near real time. It's not some dude that did analytics 6 months ago. It's not a database that takes 9 months to build. It's like literally in 7 to 10 days, we can digital twin your environment and start building machine learning algorithms for your environment. And that's not a sales pitch. That's why I'm an ad hoc research. You get to see a lot of tools when you're a modeling and simulation person, right? And then on the right-hand side, there's this idea of emulation, right? And we won't get into that because I probably have 1 minute left, but this idea of building behaviors, and it's EWIO, cyber information operations. And people are like, yeah, that's great. Well, show me how you do it. Okay. Well, what website you want to go crawl or scrape? And what Twitter bots you want to bring in to the environment? And what are you trying to look at? What are you trying to intel? Are you looking at human? Are you looking at sentiment analysis? Are you looking at what the current environment is today? Or you just want the weather? What do you want to try to do? So that's where we're at with that. Thanks, Lynn. And then you have the architecture. It's architecture probably where you haven't really seen before, because it all ties together, right? And so I always tell my Army brothers that you have to build once and reuse often. Okay, if we're not building once and reusing often, we're in trouble, because that's a data problem. That's a database problem. That's the absolute sole #1 gap we have in the United States Army. I used to run the Modeling and Simulation Gaps Forum for 2 years. Chad Bates came and took it over from me, and he was like, "Hey, what's the biggest problem? We gotta build it once and reuse often." And we do it. I was at Track Monterey. I was at Warfighter 2ID. I was in 1st Infantry Division. I was in 1st Cav. I was the Arctic LNO doing CDIRT Rapid Equipping Force in Afghanistan at the Tactical Edge, refitting out of Tillman. What? No, we gotta build it. We gotta save all our lessons learned. Same thing in modeling and simulation. If we're not saving it and reusing often, adding new and existing capabilities to that framework, then conducting analytics to make smarter S&T investments, we're wrong. All right.
Excellent. Yeah. Okay. We unfortunately don't have time for questions, but you guys will be at the demo.
We will.
Yes. Excellent.
Yep.
So that'll be good. So you can ask Pritesh and Bill anything over there, and I think you've understood that Bill will definitely give you a straight answer. So thank you very much. Okay, well, let's load. I'll go ahead and do the quick introduction. We're very lucky to have another Moves grad here, Colonel Walt Yates, who's he's representing Unreal right now, but as I understand, you're a kind of like your own company there right now, and you're doing contracting work?
Independent consultant. I work about half-time for Epic Games, and here to talk today about Unreal Engine 5, which is the latest iteration of Epic Games' one product. Really, everything else is an application built on top of it. But as Perry's getting this loaded up, I was a fan of Unreal Engine for many years, since the time I was started here at NPS. and it was being used a couple of years before I got here. America's Army debuted, and they used Unreal Engine because it was probably the only general purpose game engine that was available. And they licensed it at some considerable expense. I think Rudy mentioned they were paying about $2 million a year to have unlimited distribution of America's Army built on Unreal Engine at that time. Things progressed. Epic Games is now 30 years old as a company, and they produce a major release every 6 years. And they changed the licensing model around 2015 when the founder and CEO, Tim Sweeney, decided, you know, I'm a game company. This is where I want to make all of my revenue. I don't want to bid on government contracts or do contract work for industry. I want to make games, but I need my platform to be tested and used across other industries: simulation, automotive, architectural engineering, movies and television, and real-time broadcast or in-camera special effects. So that was a decision that led him to open source it and create new end user license agreements for everything other than games. So this presentation is about applications, simulation applications built on Unreal Engine. It's Epic Games is now 30 years old, headquartered in Cary, North Carolina, 15 countries, 2,600 employees. Probably best known today for their flagship game, Fortnite. These numbers are a couple years old, but as of 2020, at any given moment around the clock, 24/7, 365, 15.3 million players on Fortnite, and not counting the other portfolio of games. So what do we do? We have Fortnite, Rocket League, other Epic Games published portfolios, and there are hundreds of games that other companies build on Unreal Engine and for which they pay a royalty, 5% royalty after their first $1 million. These are the other industries that I mentioned, the focus industries, for which Unreal Engine is made available at no license fee or royalties. So simulation and games have a lot of overlap and common interests. And the technical parameters of Unreal Engine can support both and do it very well. A little bit of boilerplate about how we view Unreal Engine as a platform. It's an open, user-centric game engine. And getting on, I want to go as fast as possible. I'm going to run out of time on the slides, but talk to you about some of the features in Unreal Engine 5. So what this video is showing you is a feature called World Partition, where you have two independent actors going in different directions in the world. And those grid squares represent terrain data that's being streamed in real time to those eye points. So you very efficiently provide the highest polygon count where you need it, so it looks visually amazing, cinematic quality, but you don't render things that you don't need to at a time that you don't need to. This is efficient both for your network transport and also for the GPU provisioning. So one of the biggest, most impressive and gratifying comments from people that migrated from Unreal 4 to Unreal 5 and began to take advantage of some of the new features was that my hardware is not obsolete. It runs just as well because of the efficiency that has been built into Unreal 5. UE5 is photorealistic. Even before Unreal 5, you may be aware Disney was filming The Mandalorian, and over 250 other movies and feature television series are filmed against a backdrop of Unreal Engine in LED digital sound stages. So rather than filming on site and all of the costs associated with that, Epic Games has a big commitment to supporting movies and television because of the high demand for the best quality. What you're seeing on the left here is some video taken from a 12-minute simulation tie-in to the new Matrix movie called The Matrix Awakens that shows how a lot of the visual special effects were done for The Matrix. All of those trucks and cars and vehicles in this 12-minute simulation are drivable. You can jump in there. You can actually download this urban core, which I believe is about 6 kilometers by 5 by 6 kilometers, something like that, and play it and jump in there and modify it and understand that. What you're seeing on the right is the new feature called the mass entity and mass crowd model. So all of the data of those non-player characters is being displayed. And Unreal Engine 5 does something really interesting in that it creates a AI levels of detail. And it can be summarized in this, that basically the closer a non-player character or an AI entity gets to you, the smarter they get. The farther away, the less computational resources are expended, because they look pretty smart at a distance, but by the time they get close to you, if you have a collision or something, they'll actually say, excuse me, I'm sorry I got in your way, and be very high fidelity. You can have a conversation with them. But when they're not far, not that close, they're more efficient in the computational resources. So talking about licensing, the standard license has all of these attributes on the left. If you want it, I say it's free. There's no license fee, no royalty. That is true. If you're going to build a business on this, you probably would like to subscribe to Unreal Enterprise Program, which is $1,500 per seat per year. That's not really a revenue generating proposition for Epic Games, but that's to prioritize who gets the account support, who gets an answer to their questions, and prioritized assistance. And we can also do custom license agreements so that you get the level of support you need. And I would liken this to, in the operating systems world, the difference between CentOS and Red Hat is really the support after the sale. It's the same OS, but if you need to prioritize support for mission critical stuff, it's probably worth it to buy a Red Hat Enterprise license. And it's similarly, Unreal Enterprise Program provides you that Epic Games technical support, an account representative, et cetera. How we describe Unreal Engine is, in the future, is the platform for real-time 3D. Whatever your application domain is, we want Unreal Engine to be the way that you would prefer to provide that. So here's a brief process flow diagram, starting with content creation, going to scenario execution, and then training and analyst interactions. I won't belabor the bubbles on this screen. I'll leave the slides behind, and they have more detail with those. It's an Unreal Engine is open source, open API. We don't want to make anybody choose tools that they use with it. We want to have everything able to be plugged in and to have functionality and interact with that. Underneath the hood, it's built on C++. Unreal Engine as a user interface and development environment is really an IDE that cranks out C++ code underneath the hood. But for non-programmers, we have a graphic user interface that looks a whole lot like Arnie Buss's VizKit event graph to drop and connect things together for non-programmers and non-coders. In terms of, okay, can I use this for government applications? How do applications built in Unreal Engine fit into the requirements for the risk management framework for cybersecurity? The Air Force Agency for Modeling and Simulation did a deep dive, did automated source code review and assessment, identified vulnerabilities, mitigations, et cetera, and issued a certificate for Unreal Engine 5.x and also 4.x, so that you can take this to your AO and have him make a risk-based decision on, should I use, is it okay to use Unreal Engine in this environment? So we haven't had anybody run into a brick wall that said, we can't use Unreal Engine after having looked at the vulnerabilities, the risk assessment, and it's built to be as robust as you need it to be, secure. You can download the source code from GitHub, compile it in a high-side environment, and do your own development there if that's what your mission requires. I'd be happy to provide that document to you. Let's see, I think I skipped a couple of. Okay, okay, environment models, just a little bit of talk to talk a little bit about pipeline tools, creation tools, libraries, and streaming. We let you choose the data format for GIS, for your models and dynamics underneath the hood. That's all up to the user and creator. Datasmith is our means for ingesting a variety of industry standard formats and making them accessible for applications in Unreal Engine. So 3ds Max, Autodesk products, XREI, Maya, et cetera, those can all be brought in and have that accessible inside Unreal Engine. This is a a blueprint screen that shows how you can drag actors together and events and create your game logic. And you're not starting from scratch. You don't have to create everything. The Unreal Marketplace lets you buy, thousands and thousands of different types of assets, from vehicles, weapons, terrain, urban and areas, built up areas. The Quixel Megascan library has scanned pieces, everything from a rock to a whole tile of terrain that you can use. Companies such as Vigilante, Synthetic, they libraries of military vehicles, highly articulated, every joint and hinge, control surface will move, and you can license those right off license them off the Unreal Marketplace to use in your applications. So you don't have to be a digital artist to get high quality. Just spoke about the Quixel Megascan libraries. Quixel was a company that was acquired by Epic Games in 2019 and is now in Unreal 5 through the Bridge application. You can pull scans, photogrammetry directly into your Unreal Engine projects. Okay, so leveraging expertise. This lists several of the geospatial data formats that have plugins, or you can bring into to Unreal Engine to develop your applications. If there's one that's not up there and you need it, you can probably find somebody who's created a plugin for it or create a plugin for it yourself. Unreal Engine, Danny was speaking about the game engines are mostly 32-bit and simulation environments are 64. That was a big issue for Epic Games in becoming seriously committed to supporting simulation applications, because for things like civil aviation, military training, flight simulations, or global round Earth navigation, you have to have double precision coordinates. In 32-bit float coordinates, which make game engines run fast and look really beautiful, you accumulate error the farther you go. So every few hundred miles, you have to do an ugly workaround to re-baseline and get back into position. Unreal Engine 5 is 64-bit double precision coordinates natively. So the way I like to put it, what does that mean in terms of precision? It means that if you could throw a hand grenade from the Earth to the moon, the error would be within inside the frag radius, actually in centimeters. So that extra 2 to the 32nd power precision makes it suitable for Earth to moon to Mars navigation. And we've actually had a discussion with somebody who was building a lunar lander trainer for the return to the moon mission. And their big question was, okay, how do we go from Earth-centered coordinate system to do lunar landing? It's like, well, you just pick the point in the transit in between where you want to switch over from Earth-centered coordinate system to lunographic coordinate system. And it's that easy. It's a decision on when and where you do that. Already talked about large terrain databases, XREI ArcGIS SDK, CDB format. Also, we have plugins for that. Cesium is developed the technology that the Army adopted as the basis for One World Terrain, their 3D tiles. And Cesium received a mega grant from Epic Games to build a plugin. So now you can use their efficient 3D tiles format to stream terrain into simulations from their Cesium Ion server. The Project Anywhere that Microsoft was discussing earlier, there was a collaboration between Microsoft, Epic Games, and NVIDIA. Azure hosted, provisioned with GPUs from NVIDIA, running on Unreal Engine 4. That was using Cesium terrain streamed into it for that orbit to Earth and back up view. Okay, and also VBS World Server for those using Bohemia products. There is a World Server plugin for Unreal Engine to stream that World Server data into Unreal Engine. Already talked about the World Partition System. For highly realistic vegetation, we've recently released Megascan trees so that you have highly accurate, very detailed trees and vegetation that you can bring into your environments. Dr. Maria Harrington at UCF, her special niche, she's an expert with Unreal Engine, is scientifically accurate biomes. So she's done hundreds of plants, everything from the Florida Keys to the Canada border in the eastern half of the US, every tree and plant imaginable. So you could zoom right down and look into the petals of the flower and the pistil and the stamen, and it's going to look exactly realistic. The leaves and the pine needles and the fronds, reviewed by botanists, and she's loaded those in paint brushes. So you can take a terrain contour with some 2D imagery from a drone or a satellite, parse that into what are those actual plants, and then pull them into 3D in the appropriate texture. So she's got a 247-acre arboretum on the UCF Florida campus and the range science area. And if you walk through it virtually and in the real place, you're going to see the palmettos and everything, all the plants just as they should be there. Digital humans and metahumans. I won't go into too much detail on this, but if you Google metahumans and look at some of the YouTube videos, download metahuman creators, you can create cinematic quality down to the pores on the skin, follicles of hair, detailed metahumans based on no real person. You can create something that you own the likeness rights to, make movies with it. It's going to be a great cure for poorly behaved Hollywood actors. Let's see, I think I'll just end it here and offer to answer a few questions if there's any time. If not, we're going to have a demo. My colleague, Danny Williams, is going to be running Unreal Engine 5 and highlighting some of these new features, such as world partition, nanite, single pixel geometry, and Lumen software ray tracing features in Unreal Engine 5. So look forward to talking to you, and thank you.
Hey, good afternoon. So it was really fascinating, and I love the visualization. Everything is great for an end user. But does Epic Games possess a capability that could lend itself to data science or statistics and injects for other systems or models on the back end? So like you mentioned DataSmith specifically, but that's an ingest method. And do you have any capabilities of digestion? So we just ate lunch. Is there a capability to also take a simulation and just like, digestion for the body, you could break down entities, their interactions and attributes from a simulation in time so that it can be absorbed and used by the DoD warfighter or war planner?
I believe the answer is yes. Let me get, if I understand your question correctly, I'll start by talking about the chaos physics engine. So up through early days of Unreal Engine 4, we were using the physics engine, physics engine, and have migrated to an Epic Games physics engine called Chaos. So you can break down interactions between physical entities, Newtonian physics, and phenomena, and optical specular reflections, all of those things, and have that data available in exportable form. You can also, and this is very important to what Mr. Mann was talking about yesterday, Chaos is great, probably really, really close to something that could pass VB&A for specific purposes. But if you have a validated and accredited model, let's talk about model-based systems engineering example where you have a vehicle prototype, a virtual prototype, and instead of doing one developmental test and simulation, let's instantiate 100 of them and put actual Marines or soldiers driving them across the desert floor or so forth. Look at spring deflection. So you're actually creating data inputs and representative data to be analyzed in your higher fidelity model. So those are all things that we want to support in Unreal Engine. Thank you. All right. Thank you very much for your time. Look forward to talking with you at the demo this afternoon.
Great. Thanks a lot, Walt. That was really great. Thank you for viewing the videos from day 3 of the 2022 Moves Open House. If you enjoyed these, please check out the videos from day 1 and day 2, which are linked in the comments section below. Or you can go to the Moves Open House website, which is listed on the screen. Thank you.